Hello guys, welcome to another video, and this time we're going to look at paper 2 that was also written as the final examinations for 2022. So again, this will give you a review if you're a matriculant who wrote this paper to really see how you could have performed on this paper, and if you are a matriculant for this year, this will also give you an overview of your paper 2 syllabus for this year. So at least you will see how exactly you should be to definitely crack these papers. But guys, please, I will emphasize you have to practice on your own, okay? Don't be happy to watch all the time, and don't be happy to find solutions from someone else. Generate those. These videos are made so that you can have a method of achieving this by yourself, because that's the only way you can get to be strong and essentially get the marks that you want. So let's get to this paper. I cannot overly emphasize the importance of instructions, and then of course this is the one I will highlight the greatest, because there is this portion in that instruction, so you already know what is there. So please guys, read instructions, don't just jump them. Even now when you're practicing any paper, first read the instructions and try to answer with regards to the instructions. And then of course the rounding off part is also important, because you see here the dictation is that we do 2 decimal places. At times they say minimum, at times they say at least, but this time they're only saying correct to 2 decimal places unless otherwise stated. So don't make a mistake of not adhering to that instruction. Okay, let's get to question 1. This is statistics. So of course, if you're a matriculant, you would know that from grade 11 you've been doing univariate data. This time you're going to be dealing with bivariate data, which is exactly what this is all about, and the scatter plot. All right, so we're told here the matric class of a certain high school had to vote for the chairperson of the RCL. Now the scatter plot below shows the IQ. Okay, what is that? It shows the IQ of 10 learners. How many of them? 10, who received the most votes and the number of votes that they actually received. All right, and you can already tell here the interpretation of this kind of a scatter plot. You can see that these plots, they're not really forming a particular pattern. Usually we choose a linear pattern to correlate to saying perhaps intelligence quotient correlates well with the number of votes a person can get, but here there is absolutely no correlation. Okay, so there is no correlation here, because this is just all over the show. It's not really forming a particular pattern. Normally, for a good correlation, we are looking for a linear pattern, so to speak. All right, so before the election, the popularity of each, okay, so we're looking at popularity of each of the 10 learners was established, and the popularity score out of 100 was assigned to each. Okay, now the popularity scores and the number of votes of the same 10 learners who received the most votes are shown in the table below. So already this is already indicated for you, x and y. So if you were to plot this, you would know that on the y-axis you're putting the number of votes, on the x-axis you're putting the popularity score. Now what can we note about this popularity score? You can already see here that the highest popularity score here is 89. So this is 89. Now what did that amount to? 22 votes. Okay, so is that the highest number of votes here? Yes, it is. So can you see here, the more popular the individual is, the more votes they would get. Isn't it the case with our current political parties? I mean, the most popular are the ones that are getting the most votes, But the issue of intelligence, it's another one, right? So it doesn't seem to really be people who are really, really, really intelligent. Okay, let me just pause for a second. There's something I need to take care of. All right, guys, back. So now that is the story. So you can already tell here that the more popular the person is, the more votes they get. So there is almost like, from this table alone, you can tell that there is a linear correlation here. Question 1 says, calculate the mean number of votes that these 10 learners received. Remember, the number of votes, you just add them together and you divide by their total. But the next question wants a standard deviation. Now, this is all calculator work, guys. So you may as well just put that data into a calculator. So let's do it quickly. So you go to mode, you go to stat, option 3, and then there you go to option 2, which is a plus b plus x, because this is bivariate data. So you just want to put it all in there. So 32, 89, 35, 82, 50, 59, 81, 40, 79, 65. Then of course you will see that there's 10 data points there. So just make sure that you're putting the data correctly. That's just the most important here. Otherwise this thing is pretty easy. So you just make sure everything is as it's supposed to be. So you will learn how to use your calculators when you're doing statistics, if you haven't already, but I'm sure you have already learned. But if you haven't, well, you will learn. So you go for AC button, it stores your data. Now we want to deal with the mean. The mean, you go to shift, you press 1, which is stat, and then this time we're going to variance, which is 4. It's a var, okay, because we want the mean. The mean, now remember, we put x and y, so we're looking for the mean of y. So you will see y written like that for this one. So you're going to be looking for that. So that is option 5 here. And then you press an equal sign. It gives us a 15.5. So we can answer 1.1 here. Say that the mean in terms of y is equal to 15.50. Remember they said 2 decimal places, so you can put a 0 there. It's not a big deal. So that is fine. So we're getting 2 marks for that, okay? Just for the answer. So you don't really have to show the calculation. If you have, you will see those marks split. Now the standard deviation of the number of votes, again, so standard deviation, you will see something like this in terms of y. Let's get that one sorted. So you go shift again, option 1, you go to option 4, which is var. Now you're looking for this combination. That's 6. Then when you press that combination, it gives us a 4.59 to 2 decimal places. Remember, we were told that our answers must be rounded off to 2 decimal places, unless otherwise stated. So we're getting just 1 mark. All right, because the extra mark is just your calculator work. All right, guys, that's easy. Now it says the 2 learners who received fewer votes. The learners who received fewer votes. Fewer votes than 1 standard deviation below the mean were not invited for the interview. Okay, how many learners were invited? First of all, we need to know the number of learners who fell below the 1 standard deviation below the mean. So we can already tell here that this is the situation here. I don't know how to write this one. Let's just say 1 SD below mean is equal to, we'll take the mean in terms of y, we minus the standard deviation in terms of y. Then we got 15.50 minus here we got 4,59. Let's see what that is. So this is 10,91, which is effectively 11, all right, to the nearest integer. So now with this calculation, we can already tell here that how many learners scored less than that in terms of votes. It is this one here and this one there. Is there anyone else? Nope. So there were just 2 learners. So out of 10, only 8 made it. So we can just say therefore, 2 learners. Maybe let's not even say 2. Therefore, 8 learners were invited, as only 2 fell below the requirement. Yeah, that's too much English anyway. So essentially, you just calculate that score. This is the most important score because it helps you to gauge how many learners fell below this. Because anyone else who scored this and more was invited. So only learners were invited. So you get your 2 marks there. Of course, maybe the other mark is from that calculation because it was necessary. Now the question he says, determine the equation of the least squares regression line. So this is the most important. It tells us about the correlation of these data points, for those 2 variables, okay, the x and y. So here we want A and we want B, okay. So we already have put our data onto the correct form. So all we do, go shift 1, and then this time we take option 5, which is regression. It's written reg. So, and then we press option 1 for A first, and then equal sign. A is 1,77, okay, to 2 decimal places. And then you go again, shift 1. The only problem is that you just keep repeating the process. You press reg. This time you go to option 2, which gives us the B. The B is 0,22. All right. So that is fine. And now we know that this concludes that Y, whatever that, I don't know, the accent, they always put an accent there. In music, that is called an accent. I don't know what is it called mathematically. So we have Y, that thing, it's going to be 1,77 plus 0,22. Okay, so you get a mark for that and for the equation. That's how you score your 3 marks. Okay, easy questions, guys. Here you should not really be struggling at all. Now it says predict the number of votes that a learner with a popularity score of 72 will receive. Of course, we have our least squares regression, which helps us predict things. But remember, this has to be within the domain. If it is not, instead of x here, you write 72 there. Then you calculate. All right, so this is going to be 1,77 plus, oh, I'm still on stat mode. Let's just get out. So I'm just going to go to the normal mode now. 1,77 plus 0,22 into 72. This is just to try and avoid issues. So this is 17,61, which is approximately, remember, number of votes, you cannot get 17,61. So you only get whole votes. So this is going to be effectively 18 votes. Okay, so I believe the substitution here and the answer is what gives you the marks. Okay, let's keep moving. Next question, using the scatter plot, okay, and the table above, provide a reason why IQ is not a good indicator of the number of votes that a learner could receive. Well, 1.5.1, as you saw that on the table, there's no specific pattern that is forming here. It's not linear, it's not quadratic. We just don't know what's going on in here. So there is a very poor correlation. So in fact, there is no correlation whatsoever. So you can say the scatter plot shows that there is no correlation between IQ and number of votes. Okay, easy stuff. You don't want to say too much. The most important is no correlation, and you get a mark there. 1,5,2. Now it says the prediction in question 1.4 is reliable. Why is it reliable? Remember, this is reliable because 72 is a popularity score that falls within the domain. You can see here the maximum is 89 here of these 10 learners. And then of course the minimum is 35 here. Okay, 32, sorry. So 72 is within that given domain. So this is what is called an interpolation. Extrapolation is what is a little bit less accurate. In fact, it's inaccurate. But this one is more closely related to accuracy. So we can say 72, maybe we can say the popularity score of 72 falls within the given domain. Let's just say that. Okay, it falls within the given domain. Therefore, it is an interpolation. I mean, when you are a little bit more confident, you say as much as you want, as long as you are saying the right thing. So even if you just write interpolation, that's why it's correct. That's why it's more accurate or reliable. Or you can explain what do you mean by interpolation is that what you used to predict was within the domain, so it is most likely to be representative of the actual situation. Alright guys, that is it. Easy 12 marks there. Bit of a warm up. Let's quickly get to this one. Now question 2 says, a company conducted research among all its employees on what percentage of their monthly salary was spent on fuel. Okay, spending this on fuel in a particular month. Okay, the data is represented in the ogive. Again, this thing is spelled O. I don't know, or you put an H if you want, and then you can say ogive as in J. You can either say O or you can say O like that. It's ogive. Okay, don't say other things. It's ogive. I know I will be accused of there's no master of pronunciation. That is true. There is absolutely no master of pronunciation nowadays, because a lot of things are just, pronounced any way possible. But this particular one, it's called an ogive, okay? If you read texts that actually tell you exactly how you pronounce this, they will tell you it's an ogive, not an ogive or anything else, all right? So ogive, please. But you will never be asked anyway to pronounce it, so whatever you maintain, it's still okay. For it will not affect your marks. But if there were orals in your exams, you would have to say ogive or ogive. If you go on and say ogive or ogive, you will get it wrong. So you would have to say ogive, ne? So you better practice now to say it right. All right. So the ogive is called a cumulative frequency graph. So you may say that if you want to run away from that word. Okay, so what do we do with this one? Now, I always make a habit of inspecting things. So you look at this thing, you can see that it is anchored at 5. Ne? It's anchored at 5. So meaning 5 is the upper limit of the lower class that has no frequency. So meaning 5 is the lower of this next class. So that's the most important thing. So always make sure you know. So you can already tell that this space from there to there, it's a class. And then there's another class from 10 to 15. And then there's another class from 15 to 20. So you can see our classes are going in fives and so on. I won't continue now. All right. So that is important to know which one is actually a class, and you can tell that these have points that are on the graph. Okay, so those are the upper classes. Again, how do you know this? From experience, maybe we can say that. So these are upper classes of each class. If I can just be silly and show them like that. They are upper classes of each class. Not a problem. What else can we say about this one? There's something special about this one, is that as you follow this ogive, you will see that it is S-shaped. Okay, that's the usual shape of a cumulative frequency graph. It is normally S-shaped. 2, if you follow the gradients are sort of like gradually increasing, but this region right here is the region of the steepest gradient. As you can see, when you follow it, it starts easing up as well until it's flat. All right. So this area of the greatest gradient, this means this class right here. It means this is the model class of our data. Okay. Model class is having a steep gradient because it has the greatest frequencies for whatever falls within this region as compared to other areas. That's all right. The last thing you want to get out of this thing is that the last plot, which is that 60 there, it tells you about the total of the participants in this, or the total frequencies. So if this is cars, you know there are 60 cars that are being studied. If it is people, there are 60 people. So this one tells us the total of people that are involved, because we're talking about people who are using a percentage of their money for fuel. All right, so this is good. So now once you've got that under control, you can be ready to answer questions. It says now, how many people are employed? How many people are employed in this company? What did we say? The plot of the last class tells us the total. Always it gives us the total of people. So there's 60 people. See, make your life a lot easier when you interpret these things. So you can just write 60 people. It's just one mark. No need to complicate that answer. Second question says, write down the model class. Like we said, it's going to be this one with the steepest gradient. So it's 20 to 25. Okay. So now there's a bit of a situation you need to be careful of here. So we have 20, we have 25. Now we have x because this is on the x-axis. Okay. These classes are on the x-axis. Now we are going to definitely say less than and equal to 20 because we can see 20 was plotted, okay, for the class that was given. So we're going to say less than and equal to. But what about this 20? Remember this 20 right here is the upper limit of the lower class. So this is definitely greater than 20. It's not equal to 20. So that's just the most important thing. But you're walking away with one mark. I don't know what would happen if you decided to make that one there. It would be a bit disastrous, right? Because as you plot, you know that for this class, you will plot the upper limit. You don't plot the lower limit. The lower limit actually coincides with the upper limit of the lower class than this one. Okay, anyway, let's move, guys. We don't want to waste time. So it says how many employees spent more than 22.5% of their salary, of their monthly salary on fuel. Okay, now we just look for that 22.5% because we just use the graph, and the graph, this is just this region right here. So this is this part here, the halfway between 25. So this is this region right here. And then it goes to the graph, and from the graph you move horizontally like that. It's a pity now this one is a bit faded, so you can't really follow the small lines, but if you look at them, there's like 1, 2, 3, 4, Oh, now I started doing my own thing here. Let's just remove this. This is 1, 2, 3, 4, and then this goes to 10. So this is like 2, 4, 6, 8, 10. Or you can just say 10 divided by 1, 2, 3, 4, 5. It gives you 2. So that means the smallest tick is 2 units. Now, if we look here, there's like 1, 2 units. So this is 34. Okay. So now this area here is 34. Remember, these people here at 22.5% is 34 people. Okay. But now the number of people who used more than that is going to be the total minus our 34. Okay. Remember that. So our 34 is going to be taken from the total, and that number is going to be the number of people who used that much. So this is just one of the nicest things about this one. So you can just say here there is 34 people who used 22.5%. Therefore, there is say 60 minus 34 people, which is going to be equal to what? 60, well, my calculator went off. 60 minus 34. Hey, Scantina when it's 26. There is 26 people who used more than 22.5% of their salary. Of course, I'm being silly now, writing too much. You really don't have. What is key is this number right there. 2, you will get a mark for that, of course, and then you will get a mark for knowing this 34. I mean, to locate that 34 is important, so that's where the second mark is. Okay, easy. Now it says an employee spent 2,400 rands of his salary on fuel in that particular month. Determine the monthly salary of this employee if he spends 7% of his salary on fuel. Okay, this is easy. We know that 7%, we'll just let the salary be X. So just say let salary, not salary, be X. This implies that 7 over 100 multiplied by X is going to be 2,400, isn't it? Because 2,400 is 7% of the salary. So that's what happens. And then we can say therefore X is going to be equal to, so you just divide by 7 over 100. So 2,400 divided by 7 over 100 is 34,285 rands 71 cents. Okay, that's quite a good salary there. All right, it's quite a good salary right there. So of course this is in rands. The answer must have the units, isn't it? Okay, so that is good. So 2 marks, guys, so not a big deal. I guess you will get a mark. In fact, you can even get a full mark there. But if you want, you can distribute that mark into this one. All right, guys, let's just do the last question here. Now the question says, the monthly salaries of these employees remains constant. Okay, salaries don't change, and the number of liters of fuel used in each month remains constant. Okay, but the fuel price increases from 21 rands 43 cents to 22.79 per liter at the beginning of the next month. Now it says, how will the above ogive change? Okay, looking at the change of the ogive. If you thought of functions, you would know that there is a left, right shift, up and down shift. There's a flip and flop, which is reflections. So guess what? If we are getting paid the same amount of money, but we're going to need the same amount of fuel, but the fuel price has gone up, that means the percentage of the salary used will be more, okay? Because the price of fuel has increased while the salary is the same. So we're going to chow more from the salary to finance our fuel, okay? So this literally says if someone was using 10% of their salary, they will have to use more than 10% this time around. If someone was using 15%, they will have to use more than 15%. So technically, our ore drive will shift horizontally to the right. So it's going to do a right shift. So our ore drive is going to move to the right horizontally. Otherwise, everything else stays the same because it's still going to be the same 60 people that we're studying. There will still be these very same classes, but of course the classes will change a bit depending on how much now is being used. All right, so that's the thing that I believe is being looked for here. We can say now to answer the question, the ore drive is going to shift horizontally to the right. Of course, they didn't ask by how much will it change. They just said how will it be affected or how will it change. So you don't really have to calculate the percentage for which it will change. But what is important is that it will shift to the right. So I guess this is it. I think 2 marks is enough for that question. All right, guys. Let me drink some water simply. All right, guys. I am back. Yo, it was hot outside, man. I was walking in the sun there when I came back from my tasks for the day. So it's boiling hot. So I had to drink a bit of some ice cold water to try and just get myself going. My engine is overheating already. All right, guys, the best one, analytical geometry. So let's just chase this one quickly. So in the diagram, so let's see. In the diagram A, so there is point A, coordinate 4 and 2, B, coordinates 6 and 4, okay? So we have our B right here. Right, and then C, which has those 2 coordinates. So we've got ABC, basically are vertices of triangle ABC, and we can see that triangle made by those vertices. T is the midpoint of CB, so that information there is important to be expressed. So again, it's already indicated. If it was not, you would have to indicate with those lines. All right. So what do we know? If T is a midpoint, we can use that formula for calculating the average of 2 points because that will give us the point right here. So we can find that. AB, having 2 coordinates, we can actually determine the gradient. From the gradient, we can actually work out the equation of that line. From the equation of that line, we can work out the x-intercept r, as well as from the gradient, we can work out alpha. So all of the things that are written on this line, we can work out with all that is given. Not a problem. So we're told you the equation of the line AC. So that is another important piece of information. So AC is 5x minus 6y equals 8. So this is the most useless form of an equation you can ever find. So if we sort it out, we can say that AC is going to be such that we transpose x there. It's going to be y is equal to minus, no, not minus, sorry. It's going to be positive. It's going to be 5 over 6x, right? Right. And then 8 divided by 6, by minus 6 is literally going to be 4 over 3. Ne? So please, sometimes certain things you just want to work out as quickly as possible. so that you don't struggle to figure out what to do. All right, so now we know that from this equation we can work out the y-intercept. In fact, the y-intercept there, which is point S, is effectively minus 4 over 3 because the constant term is that y-intercept. So this one here, together with the sign, of course, that 4 over 3 is basically point S there, is 0 and minus 4 over 3. And then, of course, from here we can make y0 and work out f. Okay, that is what we can do with that line. Now the angle of inclination is AB. Okay, we saw what we could do there. Triangle DCT, this is DCT, okay, is drawn such that CD is parallel to BA. All right, we can see that CD is parallel to BA. So what does that tell us? If lines are parallel, they have the same gradient, right? And if we have a gradient here, we can use point C to find the equation of that line. From that equation, we can actually work out point P, its x-intercept. So we can actually do some damage there. But will we be able to find the coordinates of D? Perhaps if we can find the equation of dt or ds. That way we can use simultaneous equations. But if we don't have information on this one, we will need a little bit more to know what D would be. Or at least if someone tells us that this DCBA is a parallelogram, then we can be able to figure out a way of working it out. But at this point, D remains something we cannot solve as yet. All right, so we are told you the lines AC and DT intersect at S. We saw that. S is the y-intercept of AC. We could see it from the graph. P, F, and R are x-intercepts of DC, AC, AB respectively. So that's fine. So we already saw that we could quickly work out a lot of things. So we don't want to overly interpret our diagram. We just go straight to the questions. Calculate the gradient of AB. Very nice question right there. So this is 3.1. 3.1.1, we want the gradient of AB. Gradient of AB is going to be y at B minus y at A divided by x at B minus x at A. Okay. Now, what was y at B? Y at B is minus 4 minus y at A is 2. Okay, guys, you're going to forgive me for this back and forth because my screen is small. So that is 6 minus, I think it's a 2 up there. It's a 4. So my screen is the small screen, so there will be a bit of an up and down kind of a movement. Now let's work this out. This is minus 6 divided by 2. This is going to be minus 3. That's all right. So what does that tell us? Yes, it's already a negative gradient, so it makes sense. So it can be an issue of just a value, but the sign of that answer is convincing, so we will accept it. Here you really don't have much, but you just have to make sure your substitutions are correct. But if the sign works out a bit convincingly, there is hardly any chance that your answer is wrong. So correct substitution is a mark, and then your final answer. So that's an easy question. Now it says calculate the size of theta, alpha. So alpha is that angle of inclination, and we know that there is this story here in analytical geometry that says tan alpha, which is the angle of inclination of a line, it is going to be equal to the gradient of that line, which is AB. And we just found it above. So therefore alpha is going to be shift. By the way, we need to sort this one out. So already I will do some gymnastics here that you guys are already familiar. You've been doing this from grade 11 already. So this is going to be shift, but you always correct for the problem because remember this is an obtuse angle. It's an angle in the second quadrant. So what this is going to give us is the negative angle. So all you do here, just going to say 180. You can either say plus arc10, of minus 3, or you can say 180 minus arc10 of just 3. You ignore the sign, ne? So some gymnastics, guys, you need to know and understand. So don't ask me why I have a plus. I'm just correcting for the negative answer I'm going to get with this one, because I didn't change the sign there. Alright, so let's do it. So it's 180 degrees minus shift 10 minus 3. So I'm getting, yeah, you see now, something is not right. Oh, I put a minus. You see this guy, I did something wrong now. 180 plus, supposed to be plus, shift 10 minus 3. But of course, to avoid any issues like I am trying to create for myself here, you just do your reference angle first and then you sort it out. So this is going to be 44 degrees to 2 decimal places. Okay, so that's the answer. Again, substituting into the correct formula, which is that one there, and then the answer. This gymnastic right there is expected of you anyway. So let's quickly finish this one. Now we are told here, calculate the coordinates of T. So it's between C and B. So that's not a problem. So 3.1.3. So we know that T is such. Okay, maybe not such, but we just go for it. T is going to be the x coordinate at T. Sorry, no. That's not true. X coordinate at P. Is that point P? No, it's point C. Yeah, when? Can say, ish, I don't know what I'm doing now. I'm becoming a bit erratic. X at C plus x at B over 2 is to, oops, not x this time around. Oops, come on, man. Y at C plus y at B over 2. All right? Which implies that our T is going to be x at C. I think it's minus 2. Okay. Plus minus is going to be minus. What is the x at? There is 6. So it's actually positive 6. So it's going to be minus 6. Sorry, plus 6. What am I saying? Divide by 2 is 2. And then y at C was minus 3. Ne? Minus, because of that sign, it's going to be minus 4 over 2. Therefore, T, now this is going to be 4 divided by 2 is a 2. And then this one is minus 7 over 2. Just leave it as that. Okay. In your lower grades, you were forced to change this into a mixed fraction. You can even do decimals. It's up to you, but it's safer to leave it like that. There's nothing that stops you from doing that. Again, here, you're getting only 2 marks, okay? So the 2 marks is actually the answer, right? But you will have to show how you got it. If you just wrote the answer, you will lose marks, okay? So don't cut the corners too much. Next question says, calculate the coordinates of S. So S is the y-intercept of CD. So we have 3.1.4. We can just say line CD was such that y is equal to 5 over 6 x minus 4 over 3. All right, so that's what we found out. We can say therefore S, okay, maybe let's do this. We can just say, we can say since S is the y-intercept, it is such that s is going to be 0 is 2 minus 4 over 3. I mean, you don't really have to do too much explaining here. You can also try and show the calculation by substituting x for 0 and wara wara. But here I already know that if I'm saying this is, maybe let's just say it implies now that x is equal to 0, therefore s is that. So, because if you put a 0 there, this is what we get. Okay, not a problem. So you get 2 marks here. I do believe, though, that writing this equation in that form is a bit, more important than other things because it gives us the solution. Or you can simply just work out things as they look. It's not a big deal. So you can get 2 marks, in fact, for the answer because that equation was given anyway. Alright guys, so let's continue. So 3.2 says determine the equation of CD in the form y equals mx plus c. We said the gradient of CD is going to be equal to the gradient of AB or BA. Why? Because these are parallel lines. Okay, so we are here now. So we can say now the gradient of CD is going to be equal to the gradient of AB. What is that? It is given that CD is parallel to AB. Done. You don't have to explain that. Therefore, MCD is going to be equal to minus 3 as well. So this implies that y is equal to minus 3x plus c. Then we have a point C there, which is minus 2 is to minus 3, such that minus 3 is equal to minus 3 into minus 2 plus c. Therefore, c is equal to, let me just double check my point C in case I'm writing a mistake there. And then let's see, what is that? Now, what we can gather here is that C will be equal to, this is plus 6. When it goes that side, it adds to the minus 3. We get a minus 9. Therefore, line CD is such that y is equal to 3x minus 9, okay? Or you can just simply write that is the story. Just complicating life a little bit. Just to get you familiarized with a few notations in maths, okay? Not a big deal otherwise. Now, what is important is recognizing that the gradient is that one, finding that y-intercept and getting the equation in the form that they asked is your 3 marks, okay? This form just simply says it's linear, okay? That's all. Alright guys, so let's do these questions quickly. It says now calculate the size of DCA. Alright, now what is DCA? If you think about it, DCA is this angle right here. It is this angle. Okay, so how do we find that angle? So if we become a bit skilled at doing certain questions, there's plenty of ways you can think about it, but what I'm seeing that is quick for me is to focus on this triangle here. I'll just outline this blue triangle here. So just check this triangle a little bit. Alright, so this outlined triangle, and then we're going to produce this side to D. Okay, so what do we know about this triangle? There's a few things we can do about it. First of all, if we find this angle, if we find that angle, that becomes an exterior angle of this triangle, isn't it? Great. But now what is that angle equal to? It is equal to alpha. Why? These are corresponding angles. Remember, we're told that this line is parallel to that. So these lines are parallel. So with parallel lines, we know that the x-axis being the transversal line, it gives us that angle. So we can just say alpha is equal to dpo or dpf, however we want to name that angle. 2, we want to know this angle here. Okay, maybe let's use another color so that they don't look like they are equal. That's not what we're implying here. So this angle here, which we can call AFR, is equal to this angle here. Why? These are vertically opposite angles. Great. So if we calculate this angle here from this gradient, which we already know, we will eventually have that angle, say PFC. Now we know that this angle DCF plus PFC will actually give us that angle, an exterior angle of a triangle. So a bit of planning will help you to crack questions easily. But if you get scared when you feel like things are a little bit disconnected, you will always feel like you are burning, and yet you are not. So 3 point, oops. So this is 3.3.1. We can say in triangle. Okay. Yeah, maybe let's just start then. Say in triangle, we said it's going to be PFC. What about that triangle PFC? There's a few things we want to work out here. We decided that we're going to say fine P, sorry, not P, but D, DPO, right? We can just call it DPO or DPF. DPO is equal to angle alpha, which is equal to 108, comma, sorry, what did we get for alpha there? It's comma 44 degrees. The reason is these are corresponding angles. And you always state the pair of lines. We were told that CD is parallel to BA. So this is important, okay? Because it is the logical sense that this is the situation. We can say here also, now we're going to start in general. I don't know if this is going to make any sense, you know. We can also say now PFC is equal to what? AFR. That's what we want. This is vertically opposite angles. That's very obvious. We already worked it out. Now, what does that mean? This means that this is going to be effectively equal to the tangent of the gradient CD. Tangent of, it's going to be tangent of the gradient of that line. So we don't want to explain too much. What did we find? It was 5/6, okay? Please, guys, sometimes you just have to move quickly because you don't want to waste time. So 5/6 is the gradient of line CD. You already know that this angle is the angle of inclination of CD. So let's do that. So 10 of 5/6 is what? You are bugging. Wait a minute. What is the gradient of CD? Yeah, it's 5/6 in J. Oh no. 10 alpha is, so this is shift 10, man, not 10 that thing. Yo. So this is shift 10, that, which is that. Shift 10 of 5/6. I was surprised the angle was just too small. So 39, comma. Now you can make more decimals after this because this is not the final answer. So these ones I think are reasonable to put. And then of course we can say degrees. Since this is an intermediate step, it's not the answer as yet. So let's quickly deal with this situation and say now, once we know that this angle is this one, we can say it implies therefore that angle DCA, or did they say DCF? What was the, yeah, DCA. We know that angle DCA plus this angle AFR, no, not AFR, but what is that angle? PFC is going to be equal to angle DPO. Now what is the reason there? This is the exterior angle of triangle. Remember, our opening statement said in triangle, so everything we worked out here has to be in that triangle so that we don't have to overly explain things too much. It simplifies our life when we put some subtopics or subheadings there. So this also implies we are interested in DCA. It's going to be DPO minus PFC. Now what was DPO? We got 108.44 degrees minus this 39.80557 degrees. Now we can finally round off 108.44 minus 39.80557. Now this time we can do 68.63 degrees. Remember, the final answer is the only one that you round off. So if you were not asked a question and you do an intermediate step and it comes out like this, you try to be easy on your rounding off. So this one was coolish. It's a bit of Euclidean geometry. That's those questions which are a little bit difficult when you're doing analytical because they always integrate information. So you can see here it's Euclidean geometry coupled with trigonometry coupled with analytical geometry. All right, guys. So, I think it was important to find this angle. I'm sure you agree with me. And it is also equally important to find that angle because it was not given. Now, the next statement that is important is this one because it links all these angles. The rest of the gymnastics thereafter is not important. So this is how you score those 4 marks. So do you see a bit of work? A bit of work, guys. So akudlalwa la. So 3.3.2. So these are the questions that chow time. So this is why you have to chow the easy ones as fast as you can. But my advice is if you're doing these exams, practice these ones such that you finish questions, the first 4 questions in 1 hour, okay? The first 4 questions must be down in 1 hour, okay? That way you're going to do well because you'll be able to combine trigonometry and parts of Euclidean geometry for the second hour. Then the third hour you're finishing up, okay? Don't kill yourself. All right, next question says, calculate the area of POSC. So what is POSC? So now POSC here is POSC. So this is this one here. So we are splitting things here. So POSC is basically this quadrilateral right here. All right, so you can already see that this is a quadrilateral, so it doesn't really take a form of a trapezium so that you can, use whatever you can. So this one is a bit tricky. So what I would propose we should do is to look at this triangle. This triangle is rich, okay? If we look at this triangle right here, you look at that red triangle, and you also look at this small portion of it here. That triangle, let's shade it so that it's nicer. Okay, so if you're looking at it, you will see that there is this little small shaded triangle within this big triangle. What is important about it is because if we work out P, for example, and we work out F, because we have equations for those two lines, all right? We already have that point. We don't need to worry. If we look at that big triangle here, the red one, look at the red triangle. I'm going to use the red mark here to show its height. You would agree with me that the height of this triangle, ne, is basically the distance of point C from the x-axis. And what is that? It is effectively this guy, 3 units, because it's -3, so it's vertically down. Now if I have point P and point F, that gives me the coordinates of F and P. The x coordinates, they simply subtract to give me that distance. So I can get the base of that triangle multiplied by the height of that triangle. So maybe let's call this height h. Let's call this height h. So make sure when you do this, you show it. 2, if I have f as I would have calculated f, I already know the origin is 0. I already know that here at S I have 0 and -4/3. So I already know that the distance from 0 to S is basically 4/3 units. So if I find the coordinate of F here, it will literally be the distance from 0 to F. Now what do you know about the origin again? You know that the origin is 90 degrees to the y-axis. The x-axis and 90 degrees to the y-axis. So I can use OF as my base and OS as my height of that triangle. So what do I do with these two triangles? If I take the area of the big triangle and subtract the area of that small triangle, it leaves me the area of that quadrilateral that I'm looking for. So let's go and do this one. So you see a little bit of planning, but again, it's not going to be easy because you have to do a lot of work before you can get your answer. So let's start by P. We know that P is such that, remember, it's the x-intercept of CD. So it's such that 0, we just use that equation of CD. And what did we find? We got -3x -9. Yeah, this one. P is such that 0 is equal to -3x -9. You're already just working out things here because, this is just ridiculous if you're going to try and overly explain things. But if you want, there's nothing wrong with that. So we know that x is going to be equal to here. Transpose 9, it becomes +9 divided by -3 is -3. All right. So we can say therefore P is the point -3 is to 0. This is important. This is important. You can say here also F is also such that, remember, it's an x-intercept of CD. CD was given in 2 forms, so you can decide, but I just write the one that I did. It's 5/6 x -4/3. Right, so we transpose that one. We're going to get 4/3 divided by 5/6. So what do we get? We get 8/5. So this is going to be, therefore x here is going to be 8/5. Yeah, that's not, it's 1,6. Okay, 8/5. We can say therefore F is this point 8/5 and 0. Okay, those are the most important points in your planning. So now we're ready to attack, because look, our puzzle is complete. With just those 2 points, our lives are made a lot easier. So we can simply say, now that we have everything in order, all we can say here, we can say this implies that area of POSC is going to be equal to the area of triangle. What was that one? We can say it's CFP, ne? Or CFP. Let's just double check. So there's just gonna be a bit of a back and forth, guys. Bear with me. CFP, yes, minus the area. Okay, did I just write CFP with CFP? No, it's not just CF, but triangle CFP minus area of triangle. That one was OFS. Okay, the Orange Free State, you know what I mean. So we know that this is going to be half of the basal side is PF for this one, multiplied by H. We called it H. Okay, minus half. The basal side here is going to be OF, ne? Multiplied by the height, it becomes OS. So this one had some letters that we could use. So this is half. Now PF is always going to be the x-coordinate at F, which is 8/5 minus, now remember we're going to say minus that one, so it's going to be minus 3 is going to be plus 3. And then the height, we know that that point C was effectively 3 units from the y-axis, or from the origin, so it's 3 units. So that H is exactly the same as the distance that this one would go, so 3 units, 3. So certain things, guys, you need to work out fast. Others, you just complex them. Be comfortable working out certain complicated things. So this one is into 8/5 multiplied by, okay, maybe let's just do it this way. Yeah, I'm losing a bit of time now. I'm seeing that the height of this one, OS, remember that was 4/3. Okay, so it's already a complicated calculation, so we don't want to overly explain things. So let's do this one. So this one is going to be 8/5 plus 3, ne? And then we multiply by 3. And then to this one we subtract 0,5 into 8/5 times 4/3. Alright, so now what I'm getting, guys, here is 5,83 square units. Alright, so that is it. I don't know. When a calculation gets this complicated, there is a lot of room for errors, okay? So make sure you double check that everything is done correctly. But if your planning is very elaborate and people can follow your pattern of thought, it's much easier to really forgive a few other things, especially when the plan looks very sensible and solid and mathematical at best. Alright, guys, so that is it about that question. We're getting 5 marks, so let's see if we can find ways of marking this. Of course, point P, looking at our plan, is a critical step. And point F, this is point F, looking at our step, it was also critical. And then I would say this gymnastic is really smart. You need to be awarded marks for that. And then we can say correct substitution. Of course, there's a lot to explain here, but everyone is going to understand. It's already too complicated because the answer is certainly going to carry some marks. So that's how you deal with that question. So let's quickly get through question 4. Question 4 says in the diagram, M, which is the point 3 is to minus 5, and we can see there that point M is our center of the circle, having Pn as a diameter, so this is the diameter. So these are very important statements to keep in mind because they help us a lot. KL is a tangent, to the circle at n, which is minus 7 is to minus 2. Okay, so quickly, what do we know about the tangent and the radius or the diameter? They are perpendicular. So if they are perpendicular, it means we can actually use the radius gradient or the diameter's gradient to find the gradient of KL. And from getting that, we can use point N to find the equation of KL if it is ever asked for. And if any weird reason they want the area of this quadrilateral, would have to find the x-intercept. We would use the equation to get that. Okay, cool. So we've got 2 points, center and a point on the circumference. We can actually work out the equation of the circle as well. And knowing that we can find the gradient of this radius or diameter using any point, we can actually find the equation of this diameter. And from knowing that we have the equation of the circle and the equation of this diameter, we can use simultaneous equations to find point P. Or, knowing that this is the diameter and that is the center, we can actually use the midpoint expression, which is much simpler, to find the coordinates of point P. Okay, let's just rush into it. There's not much here to say. So calculate the coordinates of P. So we use the easy way. So we get 4.4. Now it's 4.1 actually. So the coordinates of P is going to be, well, the x at P plus the x at N, over 2, giving us the x coordinate at M, isn't it? That is going to be is to y at P plus y at N over 2, giving us our y at M. So I'm just trying to put everything together. So you are interested in the x at P plus x at N is what? Is 7. That all over 2. What is x at M? Is 3. So that is the story right there. Y at P plus, now the y at N is minus 2, so it's going to be minus 2 over 2 is equal to y at M, which is minus 5. Okay. Now at this stage, once you've done your conclusions, you just work the answer. Now the gymnastics that you want to do, you cross multiply 2, you get 6, and then you transpose 7, becomes minus 7, so you get minus 1 is 2. Here again, the gymnastic is to cross multiply 2 there, you get minus 10. You transpose the 2, it becomes a plus 2, so we get a minus 8. Okay, does it make sense? Of course, if P is below M and we're getting minus 8, it makes sense for the y coordinate. And you can see it's not very far from the from the origin, so it should be minus 1. Of course, diagrams are not drawn to scale, but the answers are satisfactory. We're getting both sets are negative, so they make sense. So there's room to accepting them. So you're only getting 2 marks. So now the next one says determine the equation of, okay, so let's work this one out. So 4.2, we've got 4.2.1. We want the equation of the circle. Okay, not a problem. So the equation of the circle is going to be x. Remember this format, if the y coordinate was positive, when you put it inside it becomes negative, so that is minus, what was that? 3 all squared plus y. That one was positive, it's going to be plus 5 all squared is equal to r squared. That's what we're going to say. And then through point N, which is 7, is to minus 2. Let's just double check. Yes, it will be such that 7 minus 3 all squared plus here minus 2 plus 5 all squared is going to give us r squared. Therefore r squared is going to be 25. Okay, because this is going to be 4. 4 squared is 16. This is 3. 3 squared is 9. 16 plus 9 is 25. We'll leave it like that. You can say, therefore, the equation of our circle is like this. Okay, not a problem. So that's the answer. So again, we were just scoring 2 marks or 3. They became a bit generous, of course, substitution and that, and then the final answer. Okay, not a problem. So 4.2.2, what is required? The equation of KL in the linear form. Okay, not a problem. Now, we know that we need the gradient of MN and to find KL. So we're going to plan our attack here. MKL multiplied by M of MN is equal to -1. The reason is that the tangent is perpendicular to radius. Easy. You don't want to complicate your life. So MKL into, now this one you sort out. So x at n is 7 minus the x at m was 3. So it's going to be minus, what am I doing? Starting with the y values. So y at n was -2 minus 3 over 7 minus 3. I hope I'm not making a mistake here. Let's just double check here. The y at n is -2 minus 5. Okay. All right. So this is -5. Okay. So this is equal to -1. So let me double check the x. Yeah, it's working out nicely. So once you get to this step, you just want to make the conclusion. The gradient of KL is going to be what you get. This one divide by that. So it's -1 divide by. Now let's sort this one out. This is going to be -7 -7. Did I say minus? Remember, we are subtracting, so it becomes a plus. Yeah, when? What is going on with me today? Skies are so mister. So this becomes a 3 over 4. So is it minus? It's positive. Yeah, the heat is working on me. My other situation is that I'm panicking because of the time. So this is -4 over 3. Okay. So this implies that KL, line KL, is such that y is equal to -4 over 3x plus c. We know that point N, which is 7, is to -2, passes through, this line passes through this point. So we're going to have -2 equals -4 over 3 into 7 plus c. Therefore, c is what? So we're multiplying this by 7. So this is effectively 28, -28 over 3. And then when we transpose it, it becomes positive. So this is 28 over 3 minus 2, which gives us a positive 22 over 3. Okay. So therefore therefore y, we already explained there that we're talking about KL. So we can say therefore y is equal to -4 over 3x plus 22 over 3. So that's the equation of KL. So that was not too bad. How many marks were there? 5 marks. Okay, it's worthy. So this statement is important, and actually this gradient is important, and that gradient is important, and getting the c is important, and the final equation. So that's how you score those 5 marks. Now let's deal with 4.3 as fast as we can if time allows. Now I told you for which values of k will y equals minus 4 over 3x plus k. So what do you see here? This is the same, it has the same gradient. It has the same gradient as what we just calculated above. Do you see that? So if it has the same gradient, it means this line is parallel to KL. Okay? So now for what values of k, meaning the y-intercept, remember k is the y-intercept. So the variety here now is the y-intercepts of this line. We can vary the y-intercepts. When will it become a secant to the circle? Meaning it has to cut the circle at 2 points. So let's see what we need to look at here. If, for example, we say we will draw a line that is a tangent here. We will see that this line should be parallel to this tangent as well. Okay, let's just make sure we show that those lines are parallel. I'm not sure what's going on in there. How God. Okay, so those two lines will be parallel, obviously. But what we're interested in is actually this point right here. We are interested in its y-intercept because we can see that if this line carries the same gradient as that, now we want to know what would be this y-intercept, because when we produce our y-axis upwards, okay, if we produce our y-axis upward and we also produce this line KL, we can already see that we will see something like that. So there will be its y-intercept, which we calculated is going to be 22 over 3, isn't it? Because that's the constant for KL. That is the story, okay? Now, what we need is to find this y-intercept, because this is how we can vary the y-intercepts of a line that is parallel to these two. Now, a secant will cut anywhere in between. So the secant will cut the circle at 2 points instead of cutting it at just 1 point. Okay, guys, sorry for wasting time here. These questions are a bit hectic, you know. Even this line is just not doing the things. It is not doing the things that I wanted to do. So let's try again. We want this line to be parallel to the others. It has to show that it is indeed parallel. So look, this line also should be parallel to these ones. Okay, and you can tell that the y-intercept for this particular line to be a secant, it has to be lower than the y-intercept of this tangent and be higher than the y-intercept of this tangent. Then all we can simply do is to substitute point P into this equation we've got so that we can find this y-intercept right there. That one is already there, so we can just use it. So let's say here, well, if we're looking at point P here, which is minus 1 and minus 8, we calculated that, right? Let's see what is the story with this one. We're going to get here minus 8 is equal to minus 4 over 3 into minus 1 plus k. You can say therefore k here is going to be equal to, so this becomes a positive 4 over 3. When it comes to that side, it's negative. So we're going to have minus 8 minus 4 over 3. So please use your calculators to save yourselves from a few issues. 28 over 3. We can say therefore for y equals minus 4 over 3x plus k to be a secant, it is such that, okay, maybe 2, the circle center M, it is such that k must be less than, it can't be equal to that one. It's 22 over 3, but it must be greater than, it can't be equal to, because at that point it is both a tangent there, minus 28 over 3. So usually this format is important, how you put it, and then knowing this k is important. But the other thing is that we knew that we're taking this one there, so how many marks here? 4. So maybe the fourth mark would be to substitute in there. So that's how you score those 4 marks, okay? Alright guys, so I'm losing time like crazy. Alright, so that is it. So let's come to this one. 4.4 says points A, which is T and T being the coordinates, and B are not shown on the diagram, okay? The point A, from point A, another tangent is drawn to touch the circle with center M at point B, okay? Not a problem. So let's go to the sketch and try and do something like what is being proposed. I'm just going to cut this line short. Now, we are just going to strategically put point B directly below point M, just to make life easy for ourselves. So if we have a tangent, say this tangent is going all the way to point A right here. We're told T is to T there, okay? Now, this already tells you and I that we will have a triangle. We know that the radius is always perpendicular to the tangent. So if we draw something like that, we have a right-angled triangle. But what is most important, if this is perpendicular to this line, it means the the x-coordinate there is going to be the same as the x-coordinate there, because this is point B, the point of tangency. So this is going to be 3:2. Now, if that was 5 units, we're going to go 5 units again. Remember, remember the radius is going to be 5. Why do I know it's going to be 5? We had worked out the gradient here. We worked out r squared. R squared was 25, so the square root of 25 is 5. And since it is a distance, it's just 5 units. So that is important. Remember that. But now we don't know this side. And we also don't know this side. So we have a bit of a problem. But let's read on. It says now, show that the length of the tangent AB is given by this expression. Okay, not a problem. So it's just 2 marks. Wow. So it simply means distance formula. So we can try and use that distance formula. Sorry, I failed to complete I don't know what is happening now. So what I'm saying, I failed to complete my things there. So this one, if we're moving 5 units down from -5, this is -10, okay? So that is the story. So please, you can put this B though anywhere. It doesn't really have to be here, okay? But I strategically put it there so that it can become worth my while. Now, what are you going to do here? What you've got to do is 4.4.1. We know, well, that point B, you can just say C diagram. You can say point B is going to be 3:10. Okay? You can just say C diagram. They understand why. Okay? You don't have to really explain too much there. All we also know, you can say also, we know that MB is 5 units, okay? That is the radius of circle center M. Easy. I don't know, my radius looks horrible. Okay, that's it. Okay, now we have a few calculations that we need to perform to try and finish this off. Let's just try and do it quickly, guys. I think I've wasted time. So let's say, well, AB is going to be equal to the square root of x at B minus x at A all squared plus y at B minus y at A all squared. That's just distance formula. We substitute, we get t minus, we got here 3 all squared plus t minus minus is going to be plus 10 all squared. Okay, which is going to give us what? This is t squared minus 6t plus 9 plus t squared minus, no, plus 20t plus 100. Okay, this is 2t squared. Now 20 minus 6 is plus 14t plus 109. So do you see, they said 9, so you want to say they made a mistake? Well, yeah, it feels like that because I mean for just 2 marks, guys, this is supposed to be the case, but yeah, it's not quite. All we're getting right is this one only. The rest is questionable. Okay, let's rub this one. It doesn't really take us where we want to go. Sometimes you get to these kinds of problems so that your first attempt doesn't amount to anything. Okay, so already established that this is 5 units, so our lives are a bit easier. Let's just choose to do MA instead. MA, which is now the hypotenuse of our triangle. Let's just sort MA, see what we can get. MA is going to be x at A minus x at M all squared plus y at A minus y at M all squared. Okay, correct substitution. That is t minus 3 all squared plus t minus minus 5 is going to be plus 5 all squared. Okay, we sort it out. So this is t squared minus 6t plus 9 plus t squared plus 10t plus 25. Okay, so t plus t is 2t squared. 10 minus 6 is plus 4t plus 34. Right. Yeah, there is a bit of a situation here, I'm telling you. But what is encouraging is that we have 2t, which is what is part of the expression that we're looking for. Now we have a 4t. So the foreigner is this one. So how do we reconcile this? We can be like, okay, let's just try using the distance formula because we can see we're very close. So let's use Pythagoras because remember this is a right-angled triangle. So let's use Pythagoras there and solve this mess. Okay, we don't really have to say too many things here. We can say now in implies that in triangle MBA. Well, what do we know? We know that MB is perpendicular to AB or BA. We know that the tangent is always perpendicular to radius. This has to come out because we can say now, we are just trying to prove that this is a right-angled triangle. We can say now this implies that, well, MA squared is equal to, okay, let's just do it the other way around. We can say MB squared plus plus AB squared is going to be equal to MA squared. What is the reason? Pythagoras, okay? Which also implies now that I'm getting a bit tired now. AB squared is going to be equal to this one minus that. So what is MA squared? What did we find? MA squared is going to be 2t. Okay, let's just substitute nice and easy. Okay, squared minus MB squared. Remember MB we said is 5 units, so it's 25. So we do it. What happens here? We get 2t squared plus 4t plus 34. This one is minus 25. Now this is 2t squared plus 4t. Now this one is plus 9. Voila, there you are. We can say therefore AB, when we take the square root sign, it's going to be the square root of 2t squared plus 4t plus 9. So do you see, this thing was not as easy as they just made it. I would believe, honestly, I would believe that this thing here should be 4 marks or so. But anyway, let's not argue. Maybe there's a shorter method that I am missing. Because if I'm looking at what we've had to do, honestly, it is not something light. I mean, to get this is important. And to know that this is it's 5 units, it's also important. So I don't know. Maybe let's not even mark them there. Because at this point, it is quite clear that the marks is just this correct substitution into the correct formula and the answer. But all the work needed to come out. All right, not a problem. Let's do the last question, 4.4.2. It says now determine the minimum length of AB. Sorry. Now we want to look for the minimum length of AB. Okay, so we've got here 4.4. Here when 4.4.2. Since we know that AB now is equal to the square root of 2t squared plus 4t plus 9, we know that for minimum length, it implies it is such that AB prime. Okay, I think here we need to be careful because we can't factorize this thing. Yeah, we can't factorize this thing properly so that we can get all the things we want. So we will have to first deal with this AB first. Okay, we can say this also implies that AB squared is going to be equal to this squared is just 2t squared plus 4t plus 9. You squared both sides. We can say now minimum length of AB squared, right? It is such that AB squared, we're taking the first derivative, is equal to 0. Now this implies, now when we do the derivative, then we get 4t plus 4 is equal to 0. Therefore t is equal to, transpose there, you divide by 4, we get minus 1. You can say therefore minimum length AB is going to be equal to the square root of, now 2 into t is minus 1 squared plus 4 into minus 1 plus 9. Now we solve the thing. Nice and easy. So square root of 2 into minus 1. Then of course squared plus 4 into minus 1 plus 9. So you're just getting square root of 7 units. Okay, so they didn't dictate to how many decimal places, so we can leave it however we want. Okay, so do you see, they saw that they surprised you with this kind of a problem in paper 1. So they brought it back to try and make a smile, eh? So do you see, these last 2 questions are a bit of a few applications of things, so it's not that easy, guys. It's not that easy. How many marks there? 4 marks. But 4 marks for what? Anyway, so we know what to do here. But where to? What was important, I think, to do this in is very important. And to do the actual derivative and to actually get the value of t is important. And the final answer. The substitution is not that important at this point. Okay, guys, so ideally you want to finish these first 4 questions in at least 1 hour, but I took longer because, you know, I'm the guy with Logoria or Logoria, Is it Logoria? It's Logoria. Talking too much. Anyway, guys, you're gonna hear a few noises here. My chair and table are not as stable as I like them to be, so they make noise, so forgive me for that. And also, if I throw in some stupid things, don't mind them. Okay, so this question is wrong. Okay, you all know why. So there's no one who can say they don't know why this is wrong. So I'm not even going to bother going into it. So let's just start with 5.2. It says determine the value of the following expression without using a calculator. Okay, so this is reduction formulae, grade 11. So you can't say you don't know these things. So there are three things, this is algebra, so treat it as such. So there are three things that you're going to need to know here is BODMAS. Okay, what is this BODMAS? Basically this bracket of thing, remember this would have been brackets, ordinals meaning exponents and all that, then division or multiplication, which are interchangeable. All right, these two are interchangeable, and then addition and subtraction are also interchangeable. So let's just play with our colors a bit. I'm taking the liberty to teach you anything. So these brackets off is actually brackets, okay, as well as reduction formulae. Okay, so reduction formulae in brackets, so this is what you start with. These divisions is just cancelling factors. Okay, if you've got factors, they cancel out, and then the AS is like terms. Okay, so you deal with it this way. This one, almost 90% of the time, you will solve trig expressions using that. As you would know, in arithmetic, you most likely will be using this technique. It's an arithmetic tool, but adapted for algebra. All right. This time we're adapting it for trigonometry. So the second thing you're going to need is factorization. Okay, factorization by taking out the highest common factor or doing dots, which is difference of two squares, or just polynomials. You know how to do a quadratic, you know how to do a cubic, you know how to do a quartic. How you do a quartic using factor theorem. So it's pretty much the same as doing a cubic. So from 3 and upward, you're using factor theorem. Others, you know what to do. Okay. And then the last thing that you need here is to know identities, okay? Because these are the tools that will always work when you are dealing with these questions. At least I have enough space. So please, guys, make it a point that this thing is as clear as the back of a goat, okay? Because I'm telling you, there's going to be hell to pay if you don't have this in order. Now let's deal with our expression. So this one is it's an expression because there's no equal sign. So we just simply deal with it as we want. Now, first of all, we said BODMAS. We're going to handle brackets. Remember, brackets is any reduction formulae or any brackets that essentially exist. But luckily, we only have reduction formulae. So how do we reduce this? Cos of 90 plus, it's in the second quadrant. Now, when you say 90 plus, you're using cofunctions. The cofunction, of course, is sine. But because cos is negative, that sign is going to be negative. So it's sine theta. So tick, BODMAS has worked the option 1. Number 2, we look here. This is a reduction formula that tells us we're in the third quadrant. Okay. How you know this? Well, you just have to know. So sine in the third quadrant is negative. So this is going to be minus sine theta. Plus, and then of course, the other issue here, of course, let's sort the sign. Now, remember, sine of a negative angle is an acute angle in the fourth quadrant. So this is when we're going anti-clockwise. Sorry, when we're going clockwise. Now, sine of that is negative. So negative will affect that sign. So it's going to be minus 3 sine theta. Again, all we used is reduction formulae. All right. Right. Now let's keep moving. if you don't know how I changed this, please watch my other videos on paper 2. I have shown exactly consistently how you can think about this. Let me just do it for the sake of your benefit if you are new to this channel. So this is minus 180 degrees. I'm just going to demonstrate that. Now how do you do that? So you just say sine, and then you take out the highest common factor here, which is a negative. Now once you pull out a negative, 180 becomes positive, theta becomes negative. And then you will treat this as a sine of a negative angle, but the negative angle being this whole angle right here, as compound as it is. Now sine of a negative angle is a negative, right? So 180 degrees minus theta. So hypothetically, this is a negative angle. You don't care how big it is. Then you sort it out. So sine of 180 minus theta is basically sine theta. But because of that negative, it drags the negative. So that's why it's there, okay? Please, guys, practice grade 11 work and make sure it is on point. So let's sort this thing out. Now, what do we do here? Now, do we have any factors? Do we have a dm there? Yeah, they look like they're there, but they're not exactly in the nice format because we have one term in the numerator. We've got two terms in the denominator. So we can't really do anything here. Yes, these ones look like terms. I mean, sine theta minus 3 sine theta is effectively like terms. So technically now we're doing the AS part, like terms. So we've got minus sine theta in the numerator, minus 1 sine theta, minus 3 sine theta. What is that? It's going to be minus 4 sine theta. Now at this point, we're like, okay, option 1, can you help us here? Yes, option 1 can help us, because what we can do now, since we have one term, sine theta will cancel sine theta. That's dm. Now negative divided by negative is a positive, so it's going to be 1 over 4. It's a quarter. All right. So guys, this is how you solve these kinds of problems. You will see that this thing works. In fact, if you liked here, you could actually come to factorization, take out the highest common factor, which is minus sine theta. You would end up with something like minus sine theta over minus sine theta into, now you get 1 plus 3 inside, okay? These will still cancel. Then this is essentially 1 over 4. So there's plenty of ways you can solve this. So you can actually try option 2 to solve and then see what to do. But most likely when you do this, let me just tell you now, this guy and this guy are usually the keys to the logs, okay? If you see these as logs, these are the keys, because once you factorize or you use identities, you almost always will go back to the final common pathway, which is arithmetic manipulation, okay? Or they call it the order of operations, all right? So that is exactly what you have to do. Now, this is algebra. You want to check your answers because you don't want to end up with the wrong answer. So you decide, you just assign theta to be any angle that you can think of. So we can have here cos 90 degrees, say, plus theta, we use 2 degrees, for example, just say 2. And then we're going to divide this one by, okay, maybe let's do this one properly. Fraction pattern, cos of 90 plus 2. We're going to say theta is a 2. So we're going to have here sine of 2 minus 180, and then plus 3 sine of minus 2 inside there. And then when Scotland D now when. Okay, I needed to put brackets, but wait. I needed to put them brackets. Yabona ke siyajwayelana ke manje. Masingaqhelani sebelief doch. I'm not interested of any issues now. So please make sure you know how to. Wena man. Scotland D now wena man. Scan D now wena man. Sine of 90 plus 2. Ingazongiqhela kabi man. Sine of 2 minus 180. Why is it giving me an error now? I don't want to hear it. Bafowethu. Yes, something went wrong here. Hi, konninkinga ke manje. Oh, I put sine in the numerator. Yeah, when? You see this guy. Cos 90 plus 2. Oh. Okay, let's do it again, guys. But I mean, this is very necessary, so you can't jump this portion. It is critical, or else if you're ready for losing marks when you have worked, because that is just what you are going to do to yourself. If you want to lose marks, you're not going to check. But if you don't want to lose marks, you will check. So when I do that, I just put it to where I say theta. It gives me a quarter. So I'm sure now that this is correct. All right. So please, guys, make sure you double check. And then, of course, this conversion, that conversion, and this conversion is important. So you see already by just the first step, you have 3 marks there. So this is how very nice this is. And then you get your 4th mark as your answer. And then, of course, handling this one, factors and like terms all together, it's the extra mark. Okay. I hope you will never forget this situation. It is very important. Now 5.3 says determine the general solution of the following equation. Again, this is already factorized. This is like factorizing a quadratic, so it's already done. Once you have brackets multiplying each other with terms inside, you actually take one bracket, equate to 0 and solve. So this implies that cos x is equal to minus 2 sine, not theta but x, or we will know that sine 2x transpose 1 divided by 3 is going to be a third. Okay, that is the first step. So if you inspect what you are given, you quickly get to your solutions without wasting time. Now let's work things out nicely. Now what do we do here? You know that, well, this is very easy when you divide by cos x. Okay, because cos x will cancel, and then this one will give you tan theta, because sine of the same angle divided by cos of the same angle, it's tan of that angle. So this implies now that 2 tan x is equal to 1. Or you can even just make 10x equal to a half, because I mean there's no point in just prolonging this. You guys are matriculants now. So a lot of prolongation is not a necessity at all. And then, of course, we start here and say or. Now, all we want to do here is to solve this mess. Okay, let's first write it as it is. Now, at this step here, this is a bit tedious, so you just know what to do here. So you can say x is going to be equal to arc10. Did I say a positive half? This is a negative half. Sorry, guys, for that. This is a negative half, okay? So you know that 10 here is going to be arc10 of that plus k times 180 degrees, because the period for 10 is 180. All right, so we're just going to sort this solution first, and then of course we can say where k is an element of integers. Right, now for 10 you don't have to do too many things. You just do the arc10 of that thing and you're done. Don't even make it complicated by doing 2 solutions. They are not necessary. This thing alone already gives you those 2 solutions, so don't do it. It's not important. So here what I'm getting, this is already an answer, so it's going to be minus 26 comma to 2 decimal places is 57 degrees plus k times 180 degrees, okay, where k is an element of integers. All right, not a problem. That is done. So that's one solution. Sorted. Now let's deal with the sign. Then you can say or. Now we have 2x there is equal to. Now here arc sine, you have to consider both this as a reference angle and 180 minus, because sine is positive in the first and second quadrants. And those solutions are pretty hectic. So it's important to know that this is going to be arc sine of our third plus k times, now the period for sine is 360 degrees, All right, or now we can say 2x is going to be 180 degrees minus this arc sine of a third plus k times 360 degrees, where k is an element of integers. All right, not a big deal. This now will imply, remember that solution was already done, so we're solving these ones. Now the first one, we're going to do the arc sine, shift sine of a third. Okay, so this one is getting us 2x is equal to 19 comma say 4 aibo 10 ngathi ngokukhona ingxaki 4 7 say 1 2 degrees plus k times what 360 degrees or 2x is going to be equal to, then we take this one from 180, so this is going to be 160 degrees, sorry, not right there, 160 comma 5 2 8 degrees plus k times 360 degrees, where k is an element of integers. All right, please don't forget this busy situation. Now all we have to do now, we just divide by 2 in the numerator, so we know that x is going to be, so 19 comma 4712 divide by 2 is what? This is 9,74. Now to 2 decimal places, degrees, plus k times 360 divided by 2 is 180 degrees, or x is equal to, now we're going to take our 160 comma 5288, we divide that by 2, it gives us 80,26 degrees plus k times 180 degrees, where k is an element of integers. Not a problem. So it's a bit of a tedious amount of work, but they already factorized it for you so that it doesn't become a painful experience. So these are the solutions. So these are the general solutions. Okay, so you get a mark, of course, for these two if they are correct. I mean, at this point, it's not very easy to test anything. It's nicer when you have a graph, but if you don't have a graph, yeah, it becomes a bit of a situation. But you just have to treat it as one of those things where you just have to be cautious, but there's not so much gain you can get out of it. But it helps to find points of intersection when you have two functions and you are given graphs of those functions. Okay guys, so we've already gotten 3 marks, and then of course I think getting to these stages is pretty hectic. So we have 4 marks. 1 2 3 4 5. So where would be the 6th mark, guys? I don't know where it is. So I don't know, but maybe let's say the first step before we went anywhere. For those sorting up those brackets, you get the 6th mark. So it's not really a big deal. Alright guys, 5.4 is giving us an identity to prove. So you always will get this kind of a question. It's always there, okay? And sometimes it's also applied. So given the identity cos of x plus y times cos of x minus y is equal to 1 minus sine squared x minus sine squared y. So usually you always choose the side that looks a bit complicated because it always most likely works like that. But if you take the side that looks a bit simple or simplified, it's a bit of a situation to try and take it back to that. So I will start with the left hand side, sorry. Side 5.4.1. So we will just say left hand side is cos of x plus y times cos of x minus y. This is equal to, so I mean these are compound angles, so you expand. It's gonna be cos x times cos y. Remember, if you don't remember this, you go and consult your information sheet, okay? So when the sign is positive, it becomes minus sine x sine y, okay? That's the first thing. So we are not yet done with the brackets here because there's a multiplication. So now we're going to have to do those brackets again. So we're still dealing with brackets. So these are reduction formulae, but for compound angle identities. So in our lovely sketch, we are dealing with this one here because there was nothing we could do. So we started by using identities. So we started with step 3. So sometimes you don't really have a step 1 coming first. Then we're doing the same thing. What is that? Cos of this one is same cos of x, cos of y. The sign changes now to sine x times sine y. Okay, I'm sorry for whatever is going on in there. I didn't plan for it to look that way. Now, if you inspect here now, what do you see? You see cos x, cos y. There's cos x, cos y. Ne? What else do you see? Paper2? I'm just going to play now. Just loving the colors. Otherwise, it is not necessary. We can actually see, but I'm just shading so that you can see this is the same thing because my writing there was trying to close its own eyes. Now, what do you notice, guys? The other thing that you notice here is that the signs in between these things, you see there's a negative here, and then there's a positive. Now, you have the same thing on either side of these signs. So what does it look like? It looks like a factorized form of some polynomial. But it is factorized such that we have dots, difference of 2 squares. So do you see step 2 comes to your rescue here to interpret what you've got. So all it looks like this thing, because cos x, cos y, cos x, cos y, it means there was cos squared x times cos squared y. Ne? That's what we've got here. And then we know difference of 2 squares is going to be a negative sign. And then there was sine squared x times sine squared y. So do you see, understanding your algebra and knowing how to go around these things, you are sorted. Now, in this case, can we do anything? Of course, we don't really have like terms anymore. We don't have any factors that we can cancel out whatsoever. So we come back to step 3. So we just bounced there and then we are back. We can still use identities here because we can convert, because now remember our expression doesn't have cos, it only has sine. So you inspect what you're going into. Please don't lose me on this one. So you see the sine squared x sine y. So it means the cos squared x and cos squared y must go. But now what identities do we know? We know that cos squared x is the same as 1 minus sine squared, sorry, not y, but x, okay? For that one. This is multiplied into cos squared y is the same as 1 minus sine squared y. Then we have y minus sine squared x sine squared y, okay? Easy stuff. Now, what else do? We're back to now 1 BODMAS. So we have brackets, so we must multiply. We must deal with those brackets. So you see, I hope you can follow the pattern. So 1 by 1 is 1. 1 multiplied by that is basically going to be minus sine squared y. And then this 1 times 1 is going to be minus sine squared x. That multiplied by that is going to be plus sine squared x times sine squared y. Then minus this one now, sine squared x sine squared y. So things are just trying to be a bit situational. So we can see our 1 is there. So what do we see here? we've got these two chaps here, sine squared x multiplied by sine squared y. We've got sine squared x multiplied by sine squared y. So it's both positive and negative. So what do? They do the thing that they must do. They cancel out. So what are we left with? We're just going to write it in the format that they wanted. So it's going to be minus, sorry. So this is minus this one, sine squared x, then minus sine squared y. Isn't it the same thing? So this is equal to the right hand side. So trust me, these ones are the so-called higher order type questions. Okay, they always ask you a simpler one like the one at the top. Sometimes they can give you a very easy one, a grade 11 type of a proof. But this is a grade 12 type of a proof, so always expect it. And this one can be a bit hectic, okay? Especially if you don't choose well. You need to be very careful and crafty. If you choose this side, it's always going to be more complicated to take it back here than to take a complicated one down to a much simpler side. All right, guys, so we've done it. Not a big deal. So you can see how your tool is so NB, net nota bene. So please take any trig expression or trig identities to prove and write this out on the side, and as you work out those problems, have this in mind. I don't know what this is doing. So as you work those problems out, have this tool in mind. I promise you, these things are not going to become a problem anymore for you, because if you keep inspecting every step of the way in relation to this outline, you will always crack those examples. Of course, some are complicated, like these ones here, the last one here. They can be quite complicated, so a lot of strategizing is important. Okay. Anyway, guys, we're done. So I don't even want to say where the marks are. This thing is already complicated. But what I can say here, the expansion normally gives you marks, okay? How many marks? We're looking for 4 marks. Expansion is important, and this interpretation that this is actually difference of 2 squares is important. And then changing these two into using these identities is the 3rd mark. And then of course the final proof, how you sort it out, I don't know, because look at this. You can mark yourself here and say that is your 4th mark, or you can mark yourself at the end because you've actually proven the identity, so it doesn't really matter. All right, I did it even though I didn't want to do it. So let's do the last one. It says now, hence determine the value of 1 minus sine squared 45 minus sine squared 15 degrees without using a calculator. So 5.4.2. Okay, this question is a bit hectic. 1 minus sine squared 45 degrees minus sine squared 15 degrees. That's it. Now remember, this thing is the same as what we had, okay? So all we're going to do now, we're just going to write whatever we have in this format. We just write it in that format because we proved the identity. That's why they say hence. They know that you can just take whatever this is and try to make it like that. So all you're going to do here, you know that 45 was x, so you're going to put 45 first, okay? So this implies, okay, not implies, but is equal to, this is the same as cos of 45 degrees minus, was it minus? It was a plus 15 degrees, times cos of 45 degrees plus 15 degrees. That's how they showed it to us. Actually, they first put the plus here and then the minus here. Easy. All right, now what do we do here? Before it, we've got cos of 45 plus 15, that is 60 degrees. You know it. times cos of 45 minus 15 is just 30 degrees. Ne? So these are special angles. You need to know that cos of 60 is a half multiplied by cos of 30 degrees is root 3 over 2. Ne? So they said without using a calculator. So this is basically root 3 over 4. I think when they say don't use a calculator, if you show up with a decimal, you are a dead person, right? Yes, there's no doubt about it. There is no doubt about it. So that is it, guys. So remember, these come from your special angle. So remember that. These are mark worthy. Remember your triangles. I'm not going to show them for the sake of saving a bit of time. Okay, we're already out of time right now. So how many marks were we getting here? Just 3 marks. All right. So basically, I do believe that, trying to write it in this format, that was key. Okay. And then for those 2 lovely substitutions, that's key. And the final answer. So that's it for that question. So we are still being asked here when khantile biyana ha le kgathale batho ba modimo ai le a tshwenya ka nnete. Now consider the trigonometric expression, which is 16 sine x times cos cubed x minus 18 sine x cos x. Now it says rewrite the expression as a single trigonometric ratio. Okay, again, this is a higher order question because you can see it's complicated. So we will write here that 5.5.1 16 sine x cos cubed x minus 8 sine x cos x. This is equal to, again, remember this is a trigonometric expression, so it's more like algebra in trigonometry. So we still use our BODMAS. Do we have any like terms here that we can deal with? Not exactly. But do we then go to step number 2? Can we factorize this thing? Yeah, the answer is possibly. Possibly. Why? Because we've got sine x, we've got sine x. 16 and 8 are related. So what we can do here, what we can do here, we also have got cos x and then we've got cos x. So we can actually take out 8 sine x cos x. That is taking out the highest common factor. So what are we left with is 2. Now when we take 1 cos, remember the sine is already out. We take 1 cos here, we remain with cos squared x minus, now here this is just 1. Okay. All right. Okay. Now we have a few issues. We have a few issues now, so we are to be very, very, very crafty about our thing here. So we can see here that, look, this thing here is already a complicated scenario itself, and this one is also complicated. So what do we do now? We still use identities, but we try to deal with this one by further factorizing this and say this is the same as 4 into 2 sine x cos x, which is all together multiplied into 2 cos squared x minus 1. Okay, you just prolong that step a bit. And then what is this? This is 4. Now, remember, we're going back to the first scenario. What can we do here? Well, inside the brackets, by trying to remove the brackets, but we are faced with 2 sine of an angle multiplied by cos of that same angle. Now, using step 3, which is your identities, you know that this is the same as sine 2x times. Now, again, this bracket here, minus 2 cos squared and angle minus 1 is the same as cos 2x. Okay, great. Now you are looking at a situation that demands your further attention. Like, look, we have the same angle right here. So sine of the same angle multiplied by cos of the same angle. This 4, we can actually further factorize this thing and say this is 2 into 2 sine 2x times cos 2x. Step number 2, factorization by taking out some factor. I mean, this is just a gymnastic of splitting that 4, essentially. Again, we need to deal with this bracket now. Now, you can already tell that, look guys, we're looking at 2, but again, we have now this same angle here. So when you have sine of an angle multiplied by cos of the same angle with the 2 in front, this is again a double angle, but a much more complicated one. So this is the same as sine 4x, okay? Because you just double that. All right, guys, I am sure now you can already see that we have made this into a single trig ratio. So this is a higher order question because, you hardly will find in your textbooks this much extent, but from past exam question papers you actually do. All right, not a big deal. So do you see your BODMAS, your factorization and identities? They work, but you will have to find the balance there. So let's have a look, guys. I think the mark is important here. So this is 4 marks, so it's very critical. I think pretty much every step is crucial here. I think the marks are here though, and here and here. Okay, so that is how I think this 4 marks comes about. All right, guys, so I think we're losing a lot of time. Is there more? Yeah. Now it says for which value of values, for which value of x in the interval 0 to 90, so this is in the first quadrant, will this thing have a minimum value? So literally this question is asking us, when is this going to have a minimum value? 5.5.2. So basically, when we are asking ourselves that question, we're literally asking ourselves this question, when will this one have a minimum value? Remember, the minimum and maximum value are related to the amplitude. So when this is 1, essentially, okay, but they said for which values of what? Of x. Okay, be careful of that. X is the angle. So we know that, well, when do we get 1 with sine? We get 1 when sine is 90 degrees. So when you split 90 into 4, what is it? It's 15 degrees. 90 divided by 4. No, it's 60, man. What is that? What am I doing? Hey. No, man. Let me see again. No. Oh, for which value of x? Yeah, that is a tricky question. For which value of x will this thing have a minimum value? Okay. Minimum value, remember? I'm trying to think now. We know the minimum value is going to be at plus or minus 2. Okay, maybe we should just solve this because essentially what they gave us is this. It's going to be at plus or minus 2. We can say now okay. Yeah, it's getting a bit silly now. For minimum value, we can say it is implying, or it is such that sine x, this thing, what am I trying to say, guys? Emanyana. It means our 2 sine 4x must be equal to minus 2. Remember the negative version of it. Here, I don't see how you can solve it without doing this, guys. It's almost inevitable. So this implies that sine 4x is equal to minus 1 when you divide by 2. Then we can say, therefore, 4x is going to be equal to, I don't know why they're making it 1 mark, because this thing is not as easy. Heck. So we're going to say shift sine of minus 1. It's minus 90. Yeah, when? Why did I even use a calculator? This is a special thing, man. It's minus 90 degrees, ne? Yeah, you know it. And of course, there's two solutions there that you can think of. Wait, I don't know if this question is correct. I think this question is wrong. This question is wrong. You understand me? This question is wrong. Am I wrong? Maybe I'm wrong. Guys, come on. This thing is doing things now I don't understand, so we know that. Therefore, we know that our x must be equal to minus 90 degrees divided by 4, which is minus 45 over 3, isn't it? So let's see, over 2, no, not 3. So 90 divided by 4. Actually, I was right when I did that, 45 over 4. Okay, so this is 45 over 4, guys. So now this thing is negative. So sine is negative also in the third quadrant, which is 180 plus this angle. So it's not really helping, is it? Hi, wena, man. Hi, wena. What is that? So let's see when in the first quadrant x is positive. What do we get for this thing? We've got 2 into sine of, 4 times, say, 45 over 2. It is just 2, which is the maximum. It's not giving us a minimum when we put that as positive. When? Let's do 90 then. 45 doesn't work. Okay, let's just put 45 here. 2 sine, I don't know what I'm doing anymore. 2 sine 4 times 45 is 0. Okay, so that's fine. We're getting 0 when we're at 45. Let's see when we put 90 here. 2 sine of 90 times 4 is 0 as well. So I don't know, guys. When something is not right with this one. I'm probably not seeing what I'm supposed to see, but something is not making sense anymore here. Because sine, first off, sine will be negative in the third quadrant and fourth quadrant. And now this given domain is not really helping, is it? Unless this solution is wrong. If this solution is wrong, then that's it. What can you do? So let me check my solution here. I'll just put any value for x. So 2 sine of 4 times, let's say 2. I'm gonna choose x to be 2. I'm getting a very nasty number. Yes, son. 0,2783462,019. Okay, that's what I'm getting. Let's see when we take this and substitute with it 2. We've got 16 sine of 2 times, okay, maybe let's say times cos of, okay, maybe that one is squared. Yeah, well, now this is gonna be a bit complicated now. Into cos of x, which is 2, but we are going to cube that one. We're getting an answer there. Then we're going to say subtract 8 sine of 2 times cos of 2. So I'm getting exactly the same thing. So this solution is correct. So my solution is actually correct because I'm getting the same answer even when I'm putting a 2 in there. So nope, my solution looks alright, but then I don't understand what is going on here. So it's just 1 mark. So guys, here when I could say visual horror, what is the story? Yeah. Hayi, angizange ngayibona ke into enje. Akesoyiboni. So I think here between these, in fact, what I can say, guys, I mean the minimum value, the smallest value in this domain is 0, right? So I don't know. I'll just write x is 0. As if it is correct or incorrect, I don't care. So this one, there's no logic behind it. Besides that, when you put any values going up to 90, the least we get is when x is 0, we're getting 0, right? And then others, when you put 45, for example, you get 0. When you put 90, you get 0. So I'm not sure, man. Why didn't it come out nicely? I could say, man. But the minimum value, remember, this one is going to be the negative version of this. I don't know, guys. Let me just pause for a second here. I just need to think about this one just a little bit. Alright, guys, I'm back. So I've just had a thought about this question a little bit. So unfortunately, there's no short method here. I realized here you just have to do general solutions. I don't know why would you have to go through the trouble for just 1 mark. I think what is of note, though, is that for a minimum value, we know that 2 sine of 4x must be equal to minus 2, which means sine of 4x is going to be equal to minus 1, right? Now, what do we do here? We know that, therefore, our 4x is going to be arc sine of minus 1 plus k times 360 degrees, or 4x is going to be equal to 180 degrees minus arc sine of minus 1 plus k times 360 degrees, where k is an element of integers. I don't find an easier way. Of course, you would be asking yourself, do you really have to go through the trouble for all these marks? The answer is hell no. So you really don't. But I mean, if you think that mark is important, you go for it. All right. So which also implies what? Now we know that 4x is going to be, that one is going to be minus 90 degrees, which is essentially 270. And then we're saying plus k times 360 degrees, or x is going to be here, 4x. When we solve here, we know that we're going to get, this is 180 plus 90, it's going to give us 270 degrees plus k 360 degrees, okay, where k is an element of integers. All right, not a problem, which implies what? When we divide by 4, x is going to be minus, remember this is going to be now 45 over 2 degrees, plus 360 by 4 is going to give us what? 90 degrees, okay? Or x is going to be now 270 by 4 is, let's just see on the calculator, 270 by 4, maybe we can make this one a decimal. It doesn't make sense when it's a fraction. So 45 divided by 2 is 22.5 degrees. And then we do 270 divided by 4, it's 67.5 degrees plus k times 90 degrees, where k is an element of integers. Now you can already see, guys, that the best answer here is this one right here, because it is between 0 and 1. Because that means k must be 0. So when you multiply by 0, you're getting this one. This is definitely between 0 and 90. So you can say, therefore, x must be equal to 67.5 degrees. I don't know. I have no idea. Why would they ask a question like that? Honestly. Unless there's something that someone can use. But again, if you think about it structurally, you know that the sine graph normally is going to go 90, 180, 270, 360. And then the normal sine graph, when you draw it, it does this. Completes a cycle at 360. Of course, this is 90 degrees. This is 360 degrees. Ne? So it completes a cycle at 360 degrees. Sorry, that is 180. I don't know what is that. Now, this new graph, by the mere fact that the period, remember this affects the period. I don't know why I'm wasting time on this question. Remember, this thing affects the period. So 360 divided by 4 is 90. So it means now this graph is going to complete its cycle at exactly 90 degrees. A full cycle is completed. So all it's trying to tell us is that our graph by 90, so halfway at 45, it's going to do things like that. So you can see that, yeah, there will be some area of a minimum, but we don't know what that is. But we know that that one should be 45 right there in the middle. Now, what is that? So this is exactly what we calculated right here. But you're only getting 1 mark. But remember, this one you wouldn't see if you don't employ general solutions, because you would feel like you're getting stuck, because it'd be like, what is that minimum value? What was even that maximum value? Because that one becomes 2, this one becomes minus 2. So I don't know, guys, how this kind of a question also made it. These are some of the things we're saying that, look, Umalus is not doing their job here of moderating these papers, because unless I honestly do stand to be corrected on this one, I'm probably not seeing what they know, because I cannot actually tell what is going on. But maybe, just maybe. Remember, the other thing you think about is, the other thing that we need to think about is the fact that for a normal sine graph, there are critical points, 0, 90 degrees, and then we've got 135 degrees, and then we've got 180 degrees, and then we've got 270 degrees, and then we've got 360 degrees. So a lot of things are happening. So normally a sine graph will get a minimum. Sorry, at 90 it's a max, right? And then we know that at 135 it is what am I saying? 135 is not important here, honestly speaking. We're going in 90s. Let's do it again. So maybe the theory is that you have 90 degrees. Critical points happen at 90, honestly. 90 degrees, we've got 180 degrees, we've got 270 degrees, and then we've got 360. So maybe this is built from that fact. And then we know that a minimum here would be at 270 degrees. But now, because the period has changed, to find the new minimum, you're just going to take 270 degrees and divide by 4. And it gives us that 67.5 degrees. So I'm sure this is essentially that. Perhaps it's built from that knowledge that normally the minimum is at 270 in a normal sine graph. But because this one is a bit faster because of that period, so you take the old critical value, divide it by the coefficient of x, and then it gives you that. So probably this is how this question is to be answered. Because other than that, you can tell that, look, it's a very lengthy calculation for just 1 mark. So let's just say, since they said you can use any tools, So all you have to do is to think about this graph, that normally this is a minimum here at 270. But now when this is faster, you're just going to take a fraction of 270. Now how do you know what to divide by? You divide by 4 because the period is halved. So it makes a bit more sense. So I guess I'm wrong to make noise because I didn't see it the first time around. Now it makes a bit of sense that you can actually quickly do that. So hey guys, these people can really work on your nerves. Nah. So that means if you're going to do this calculation, then you need to show us this sketch, and then you show us the shortened version, and then you show us how these two are related. Okay, so this is not 27 right here. This is 270 baba. So you can say 270, which is the old minimum, divide by the coefficient of x. It gives us the new critical value for that minimum. So perhaps this is the story. So that one makes a bit of sense, ne? I hope so. Alright guys, let's move on. So maths is not impossible, but it needs you to take a back seat a little bit. You're not always going to cruise with maths. That one is a showcase. I don't care how well you understand it. Every now and then it gives you a bit of a knock, and that knock will cause you to think a bit more deeply, and at first you will feel like you are being punked, as we have been. But now thinking about what the whole situation looks like, it makes it easy to figure out what is going on. Alright guys, anyway, enough of the talking. Let's just answer some questions. Of course, this is who... This was 6, 7. Alright, not a problem. So that was a bit of a silly question. Let's quickly get to this one. Okay, in the diagram below, the graphs of f of x equals 10x. So you already know what a 10 graph looks like. You're not going to be told by me, so please revise it if it is not clear. And then of course g of x is equal to 2 sine 2x, a bit reasonable there. See, almost a similar situation as up here, but they put it the normal double angle way for grade 12. So this is a grade 12 equation, but you may find this one in grade 11 as well. Now I've drawn for this interval here, which is the domain. Okay, we are told a, so there's our a is 60 degrees is to k. Okay, that's easy because it defines both functions. And b are the 2 points of intersection. Alright, so we can see that b is essentially the same y value, right? Same y value, because if you look at these graphs, it is just after its first peak from baseline. Again, this is after its first peak from baseline. You don't really care from where, but from baseline, which is the x-axis, this is just after the peak. So these 2 points are symmetrical. Now, what else can we say? All right, so yeah, that's it. So what is the period of our sine graph? Remember, the period is given by the coefficient of our x. The period is 180. And do you see the sine graph is completing a full wave from 0 to 180. Why? Because here you just say period is going to be the old period, which is 360, divided by the coefficient of that angle, which is 2, which is 180 degrees. So this is how you think about these things. Again, a little bit of interpretation. Of course, experience will help you not to waste time. When you're practicing, you will definitely take a bit of time, but by the time you do your finals, this is something you will not even waste time thinking about. You won't even need to write it down. It's going to be there in your mind, okay? Next one. What is that? The 10 graph, it's just doing its own thing. Completes its cycle at 180, right? So if you look at it from 0, I know this one looks a bit complicated. I don't like this one, so let's look for something else. Now if you come from 0 for the 10 graph, it goes there, you hit the asymptote, and then past the asymptote you back to baseline. That is a full cycle. So from 0 it completes a cycle at 180. Or the other way you would want to think about it is to do this one here and say 90 to 90. You take the difference, is 90 minus 90. That gives you 180. That's a full wave of a 10 graph, okay? Which is like the mother function of a cubic function, all right? Not a problem. Let's leave that for you to discover as you study further, all right, guys? I'm not going to worry about time too much because I've already lost quite a chunk. So let's start. Write down the period. The question says write down, so you don't need to be providing any explanations when they don't want them. So we say 6.1, we know that the period is going to be, of course, I'm just showing you the calculation over 2, which is just 180 degrees. So that is it. All you write is that t equals 180 degrees. You don't show that. Just showing you the calculation because you know what? I have a condition called obsessive compulsive disorder. Well, I don't care if it makes people scared. Well, I'm just lying. I was never diagnosed, but I'm diagnosing myself. K, easy. K lies on either one of these two graphs, so we can use any one of the two. So what can we do here? We just go for the nice one. We can just simply say this was for our function of g of x, which is 2 sine 2x. We know that at point A we had 60 degrees is to k, which is such that k is going to be equal to 2 sine 2 into 60 degrees. Ooh. You can choose any, absolutely any. So this is 2 into sine of 60 by 2 is the same as sine of 120 degrees. I mean, sine of 120 is the same as sine of 60 degrees. You know that, right? From reduction formula. So that is the same thing. So sine of 60 degrees is essentially what you call is going to be, this is 2 times sine of 120 is basically root 3 over 2. It's the same as sine of 60, and those two do a number on each other, so the answer is root 3. So that was a bit of a calculation, not really so much to really worry about. I mean, if you chose 10, it would have been even easier because it's just 10 of 60, which is much quicker than this. Not a big deal. How many marks? 1 mark, yeah, obvious. You should have just chosen 10, maybe 6.3. So let's try to just finish up here. The coordinates of B, again we said this, we know that this took 60 degrees to point A from baseline. So from baseline we're going to move another 60 degrees. So we know that minus 180 plus 60 degrees is going to land us at minus 120 degrees. Ne? So that is the story. So all you do when you're moving to the right, you're just going to add 60 degrees like it was 0 plus 60 degrees lands us at 60 degrees. So guys, there's lots of tricks. I mean, you can see it's 1 mark. There's not much you need to do here. And actually, I was supposed to write 6.2.1. And then I'm going to say 6.2.2. We know that B is the point. We're just going to write here minus 180. I'm just showing you the calculation, but you don't really have to show it, guys. Honestly, it's not necessary. The y value is the same. Therefore, B is going to be minus 120 degrees is to root 3. Easy. Ne? Not a problem. Just double check on your calculator there. That's it. So the tricky part is just getting this one. This one is already implied from the top. So you're not really going to be awarded marks for that extra one. So again, it says write down the range of 2 times the function of g. Okay. So we've got here 6.3. So we know that 2 times the function of g is such that we've got 2 sine 2x, multiplied by 2. Now we want the range of that thing, so this is going to be equal to 2. No man, why am I still having a 2? 2 times 2 is going to be 4 sine 2x. We can say therefore the range is going to be equal to y value such that y, now this y is going to range, remember this coefficient here, it's going to be both plus and minus. So we're going to have here minus 4. Remember this is y this time. We're talking range, so it's going to be greater than or equal to minus 4, but less than or equal to 4. That's it. So what is that? What is that? How many marks there? 2 marks. Normally guys, you get 2 marks for this format alone, because they said write down. They didn't ask you to explain. So all of this here is your thought process. You may not need to write that. You just write this thing, you get 2 marks. But if you wrote it, it's still okay. 6.4. Now we are told here for which values of x will g of x plus 5. So what is that? That's a left horizontal shift or left horizontal translation of our function of g minus the left horizontal translation by 5 degrees of our f function, for this to be less than or equal to 0. Okay, so this is easy. The easiest way to deal with this thing is to say simply g of x plus 5 degrees is greater than, is less than or equal to, transpose this function, it becomes f of x plus 5 degrees. So all we know is the critical areas here is just to look for g. What color did we put g in our graph there? G is whatever that color is. Is it blue or is it green? It's light blue. So all we're looking for here, the critical areas here is G against F. I don't know what color did I use for F. I'm just playing, guys. I know time is already gone to almost levels that I cannot stop it. So I may as well just have fun while time is chowed. Alright folks, what we need to do here now, we're looking for the, okay, they've given us the interval, so the interval here is minus 90 to 0. So first of all, there is an equal sign, so we look for the areas where g is equal to f, okay, but in between where g is above the graph of f, okay. So let's look in the graph. You can see here from minus 90 to 0, these two are equal here and there at 0. Now the question is, if we're looking at this situation here, what is the story here? Of course, symmetry will tell you and I that if we're looking at this scenario right here, you would almost tell that from that point to 90, it's almost the same distance from 90 to that other point right here. So be very smart. Be able to know that this point is halfway between these two. So to get that point, you just simply say, what was the difference between 120 and minus 90? So let's see, minus 90 minus into minus 120. It's going to be 30 degrees, I'm sure. Yeah. So that's 30 degrees. So here, you want to move this 30 degrees to here. So you know that that's going to be 60 degrees. So this is going to be minus 60 degrees right here. So there's a lot of tricks you can use to solve this problem. Or you can say, you know that you moved 60 degrees to that point, so you will have to move a similar, distance to get to another situation, because there's lots of symmetry here. So there's a lot of things you can do, guys. I cannot overly emphasize the fact that you need to be flexible when you're solving these things. So guys, now we can tell that these are equal at minus 60 degrees and 0. But in between, because we wanted the graph of g to be also above, and you can tell here that, look, the graph of g is less. In fact, the graph of g must be below, and you can tell that indeed the graph of g, which is the sine graph, appears below the graph of tan, which is f. So it means the feasible region for our solutions is this one. It's this point and that point. Of course, less than that or equal to that, greater than that or equal to that, right there. So we have answered that, but now we're going to move those points 5 degrees to the left. So we can say now this tells us that this will happen when x is less than or equal to 0. Remember, when you're moving to the left, you're going to subtract 5 degrees. So that is the story, greater than or equal to minus 60 degrees minus 5 degrees. That is the answer. Maybe let's say this is what it is implied. Therefore, x must be less than or equal to minus 5 degrees, greater than or equal to minus 65 degrees. Okay, don't forget degrees. We're not talking about other things, but degrees. Yes. All right, guys. I spent all the time here doing nothing but wasting time. Okay, so this is sorted because we were just getting 2 marks. For the form, you get 2 marks, but do you see the thought process that you have to go through? It's a bit nice, though. It's not too complicated. Last question says 6.5, determine the values of p for which. Now they're giving us sine of x multiplied by cos of x is equal to p. We'll have exactly 2 real roots. Now this thing looks strange because we were not given a graph for this. So like I said, if you're dealing with functions, when they ask you these higher order type questions, so this is one of those questions that are just seeking to frustrate you, okay, because it doesn't look to be related at all to anything. But keyword is study what you are given. What do you notice in this graph? Well, what I notice is that I've got sine. What I notice is that I've got sine x here. And this sine x, technically, is telling me that this thing must have some relationship with the sine graph that I was given, right? It must have a relationship with that. So let's just put it down. Say, okay, we're going to try and solve this just right. But we will consider this function 2 sine 2x. Now you're like, what am I going to do with this? You'll be like, okay, from our BODMAS, this is a double angle identity. So let's just solve this thing. This thing is the same as 2 into what is sine 2x, is basically 2 sine of x cos x. Great. So now what is 2 by 2 is 4 of sine of x cos of x. All right. Now we are told that this thing is equal to p. So we can just simply say this is 4p because this is p. So multiplied by 4. Okay. So what are we trying to arrive to? We can say, therefore, we understand for a fact now that 2 sine of 2x here is equal to 4p based on what we've done. Now, what do? We are being told here that for which values of p will this give us a maximum. So technically, we can still transpose this p, because what is this p? It's a constant, so it must be some vertical shift of that function. So this is going to be 2 sine 2x minus 4p equal to 0. And then we are like, okay, thank you very much. Now we can see that this is a vertical shift. Of course, this may be up or down depending on the sign that p is going to come out as. But what works for us is that we have a function that we can identify. Now it makes a bit of sense. Now we look at the sine graph. Now we are saying this must be exactly 2 roots. So basically we are shifting our graph of sine up or down. So if we're shifting it up, you will know that that point will come there, right? And then this point will also come up there. Everything else is going to be up, right? So this graph is going to be kind of doing stuff like that, stuff like that, stuff like that. Of course, 180 is going to be flying. It's not going to come down to baseline here. It's going to be flying. So let's just cut a portion of this one. Okay. So it means we are literally shifting our axis to somewhere here. Okay. I know it's not going to be exactly good, but you will understand what I'm talking about. So we're shifting this graph that way. And in this domain, it will have exactly 2 roots because these are the only 2 roots for this domain that we were given. There will be more if we stretch it further, but there will be just there and here. All right, not a problem. And now we know very well that this is 45, but we're not interested in the values of x, but we're interested in the values of p. So that means p must be, remember the maximum here or the minimum was 2 units. So for us to move from 2 units to 0 there, we just have to move it 2 units up. Great stuff. But we can still shift it down to come here. We can shift that point down to come there, so that our resultant function looks something like this. So that point will look something like that. All right, and then it will do the things that must be done. Oh, this one is not going to do well, but it's fine. You get an idea anyway. So that means we can still shift our axis to somewhere here. Okay, spare that this looks a bit busy and not very interesting. So it means we can actually shift this up or down. We'll still get the same result of 2 roots. That means x-intercepts in the given domain. So this question is crazy. It's very crazy, but you see, when you have this function, you can already tell that this is a constant, so it must be a vertical shift. So we know that we can either be shifting this up or down, up or down. So how do we explain ourselves now? Now this is where things get a bit hot, okay? Now we can say 4p must be 2 units if it is taking a negative sign. So we can say therefore minus 4p must be equal to 2 units, because remember we want to capture for that negative. Yeah, man. Or what can we say? We can say, or we take 4p must be equal to 2 itself. Because remember, when it is 2 units, we will be shifting things down. How many units, by the way? Wait a minute. So we're moving this one. The sun. What did I do now? We moved something up 2 units or down 2 units, because that's the maximum and minimum. I'm trying to figure out what is going on here. Okay, so now this means if we are doing the upward shift, this is what we're going to write, which concludes that p must be equal to, for which values of p? P must be equal to minus a half, or p must be equal to a half, okay? That is what is important, okay? So look at this. When p is minus a half, we're going to get minus a half here. So, sorry, we're going to get a minus 2. Minus 2 is a plus 2. This is when we're shifting up, okay? This is the up part. When we're shifting it down, we simply take that p and equate it to a positive answer. We get a 2 there. So minus 2, this is when we're shifting it down. So this is the possibilities. So it's a nice question. It's not an easy one, I tell you. So this is critical and those values are critical. So this is how you get your 3 marks. So I hope you understood this one. It's not an easy question. It's a higher order question. So these are questions you need to practice and practice and practice and practice, because even I myself get buggered. As you could see, this question here buggered me, but I realized now that here they are forcing you to consider the graph, and it's just knowledge, man, integration of knowledge. But even if you did not integrate, if you know what to do, yes, you will work a bit longer and a lot harder for just 1 mark, but you will get it eventually. Or you work smarter by using this. I mean, I'm glad this came up so that at least we can see already now how easily we can get to that, which makes a bit sense. I mean, a lot of sense in why that is the answer. Okay, guys, not a problem. Whew, this guy is tired. Let me pour myself a drink. Let's just pause for a second. Today I'm not gonna go all the way without stopping. Alright guys, I'm back. So technically this is time up. If you're doing the exam, this is exactly 3 hours. They'll be telling you have 5 minutes to finish up. So don't be like me. You can't at this point still be looking to answer some more questions. But I can tell you one thing. If you're doing this exam paper, you'll have long finished, because you're not explaining anything to anybody. This is me trying to just teach you a bit while we solve at the same time. So don't really worry too much about that. Now, question 7, it's your applications of trig to some structures. AB is a vertical flagpole. Okay, there it is. We can see the angles are 90 degrees right there. And then we are told that is 5p meters long. So there is the 5p meters. AC and AD are 2 cables anchoring the flagpole. Okay, those are the anchors right here. And then okay, some things are just going to be hidden by this button over there. And then we're told here B, C, D are in the same horizontal plane. So whenever you see this, guys, whenever you see this shading, it normally tells you that these are in the same horizontal plane. So even if they didn't say that, but once they shade, just know with this type of problems, that is the standard. So BD is 2p meters. Okay. Let's just make sure we've highlighted what we are talking about. 2p meters. And then ACD is x degrees. So ACD, so it's this angle over here is x degrees. Okay. And then we are told ADC is 45 degrees, which is this other one. I mean, guys, you don't have to shade anything here. I'm just being silly. A guy with a new toy, is a problem. Maybe a girl with a new toy is something else, but a guy is a problem. That I can tell you, and you can already see it. Okay, guys, let's look in this diagram. So here it's your cosine rule, sine rule, area rule, essentially, and everything else that you know. Remember, this will effectively give you things like trig expressions. So your BODMAS, your factorization, your, what is that thing? The technique of using identities, so comes back here. So that technique, that 3-step approach of using BODMAS and using factorization in its different forms and using our trig identities in their different forms, it comes back here, but together with the cosine rule, sine rule, and the area rule. You may even use basic Euclidean geometry of triangles. All right, determine the length of AD in terms of P. So we want AD in terms of P. So that means we can look into this triangle. What can we do about that triangle? It's a right-angled triangle. So we've got 2 sides, the adjacent side, the opposite side. We're looking for the hypotenuse. So we use Pythagoras there. No issues. So let's start here. 7.1 in triangle. I always like to name my triangles ABD. All right. So all I know is that I know for a fact that AD squared is going to be equal to AB squared plus BD squared. Ne? That is it. What is this? It's Pythagoras. Just write Pythagoras, or even Pyth means Pythagoras theorem. But now we wanted AD, not just this thing. So this is going to be saying that AD is going to be equal to the square root of whatever is in here. What is AB? AB, we were told, is root 5p square, root 5p. So square root of 5 times p, and then that is squared. Plus, we were told that that is 2p, so this is going to be 2p all squared. Now when you sort this out, root 5 squared is just 5p squared, plus this is going to be 4p squared, which is giving us 9p squared, which is root 9 times p, because that's what they wanted. So it's easier to simplify to this. So this is square root of 9 only, then that multiplied by p. So that's the answer. So how many marks there? 2. Wow, that's okay. Substitution, answer. Next one, show that the length of CD is given by this ugly expression. 5 marks. So that's usually the big question in this type of questions. So let's look at 7.2. Now look, CD is in triangle ACD. Okay, triangle ACD. Now we've got two angles here that we can use. We've got X. X goes with that angle right there. Ne? And then we've got 45, which goes with that side, but we don't know that side. All right. We also don't know that angle right there. This angle here is unknown, so we can't use any trig ratios to get that angle. The x is this angle and that angle. So here we have to set up a sine rule. We know for a fact that when we've got two angles in a triangle, we can always work out the third. That's another thing I forgot to mention. So you do this quickly. So you know that this is going to be 180. You don't waste time. It's 180 minus, what is that? 45, which is going to be 135 degrees minus x. So that angle is going to be that. But of course, this is just you trying to work things out before. You just, warming the bed before you sleep in it. So let's see. We're going to say now in triangle ACD. That's our reference triangle. So we're going to work in there. What do we know? We know that angle CAD is going to be equal to 180 degrees minus 45 degrees plus x. All right. Here you can just say sum of three angles of a triangle. Which triangle? That triangle. This tells us we have 180 degrees minus 45 minus x, which is 135 degrees minus x. So this angle has to come out somehow. You're not going to get marks if you didn't do it, okay? Now, the others were given. You don't need to mention them. It's not important. So now we can set up a sine rule. We can say, then what? We're looking for a side, which is side CD. So side CD, we know that CD over the angle opposite that side is that angle we just worked out. So do you see why we needed it? So we're going to say sine of that compound angle, 135 degrees minus x, is going to be equal to, now we're going to use an angle that helps us, which is x, because the side opposite we calculated in question 1. So we're going to say here AD over sine of x, okay, is the angle opposite that side. So what is your reasoning here? This is the sine rule, okay, easy. And then you substitute. This implies what is CD is what we want. Is going to be equal to, just cross multiply this thing there. It's going to be AD. But what did we find AD to be? It's root 9 times P. So this is square root of 9 times P over sine of X multiplied by sine of 135 degrees minus X. So this is just the gymnastics that you already know from arithmetic. So we sort stuff out. So no need for no trouble here. No need for no trouble there. So we're going to have here square root of 9. Yeah, why did I leave it like this? Son, I'm stupid, ne? Very stupid. So this is 3 bafowethu. Square root of 9 is 3. Yeah, I almost left you poisoned. Anyway, if you're watching this video, you will have known that this guy is prolonging the inevitable here. It's prolonging the inevitable. Okay, that's fine. So we've got that. So we have to deal with this. Compound angle identities. So once you get an expression like this, to solve further, you decide, do you cancel anything out? Not yet. So this is 3p over sine x multiplied by, you sort this out, this is going to be sine 135 degrees times cos x minus cos 135 degrees times sine of x. So this is a bit of a complicated thing. So yeah, let's just pause. Someone is calling me. Okay guys, I'm back. So that was just a work related thing, so I had to answer. I could not ignore it. In fact, I should have put this phone on a flight mode so that I don't get interrupted, but it's fine, solved quickly. Alright guys, so now we're going to follow our thing, the BODMAS, the BOMDAS, whatever you call it, order of operations, and then we do factorizations if necessary, we do identities if necessary. You can already see here we had to use our step 3, which is sine identity for compound angles. Okay, so we've got 3p over sine x. This one can be as hectic as those proving identities and expressions in your question, whatever. Is it question 5? Yeah, usually question 5. Anyway, so let's keep moving, guys. You know that sine of 135 is the same as sine of 35, and sine is positive in the second quadrant. So there's no issues here. So here you're using special angles already. So sine of 45 is 1 over root 2. You know that, ne? Times cos of x minus. So here you use special angles whenever possible. Cos of 45, well, cos is negative in the second quadrant, so it will affect this sign, so it becomes a plus. So cos of this one is the same as 1 over root 2. But it would have been negative, so it changes that sign, multiplied by sine of x. Now, our last thing to do is to take whatever we've got here and multiply it inside FOIL method. So this is what you do. So all we do now, we break these brackets, we get here 3p times, it's going to be cos x, and then over, this one is going to be root 2 sine x plus, now we sort this one out, it's going to be 3p sine x over, so numerators just multiply each other, denominators multiply each other, root 3. Where did I get the root? Oh, root 2 sine x. Okay, now again, the final gymnastic here. You know that when you have the same denominator, this thing is literally over that denominator, root 2 sine x This is sine x. Of course, you're looking for what we call the common denominator, the CD, because it is common to both fractions. And if that is the case, we simply add the numerators. So the numerators is going to be 3p. And in fact, we can already factorize this thing because I just want to finish now. If we see here, there's a common factor, so we already factorize it. It's going to be 3p into cos x plus sine x. I'm sure that's what we're looking for. Yes, so that's done. All right, so this one can be a bit hectic. As you can see, it's not that simple. So you know that here you had to look for the common denominator, but I already have done a few steps already so that we don't waste too much time. So please save time when you can, but don't be careless. Certain steps need to come out, because if you go wrong somewhere, you lose your path and you are done. All right, not a problem, guys. So this is it. Can you see it's hectic? It's hectic. So of course, using sine rule is fine. Correct substitution right there is important. And I think using special angles here is critical. Maybe this expansion is critical as well. So we've got how many marks here? 1. Hey, why are these marks already finished now? Icon. That angle though is critical, but wait, it's very important. It had to come out. Yeah, I think that is important. The sine rule, we're not gonna give you a mark for it. We can simply say expanding this compound angle is important. Using the special angles there is important. So we've got 4 marks. The final mark is for the final answer. But I mean, the final answer was already given, so this one does not really amount to any marks. You know, what should amount to some marks here? I think it's more of the gymnastics. Don't you think factorizing this thing is what gives us the mark? Perhaps because it's a logical thing, or the gymnastic of just, you know, getting this thing like properly. So I don't know. You have seen it, guys. Let's finish up ish. Yeah, I'm losing a lot of time. It is further given that p is equal to 10. Okay, p is 10, x is 1. Okay, guys, I'm going to talk less now. I hope I will make it to 4 hours, but I'm not going to be any less than 4 hours here. I just overly indulged. I'm sorry. So we have p that is 10, x is 110 degrees. Now calculate the area of triangle ADC. So triangle of ADC. So look, we already know this side now. We know that side, we know the angle, so we can use the area rule. Easy, 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 easy. So this is, yeah, this paper was just too long, I guess, 7.3. So we can say area of triangle, triangle ADC is going to be half, say AD times CD times sine of, what is that angle there? A or CAD, let's just write CAD. So in medicine, what is this term? Of course, this is the angle. What is CAD in medicine, guys? If you are going to do medicine at some point, CAD is coronary artery disease, which is heart diseases related to hypertension when the coronary arteries have blocked up because of arteriosclerosis, which will cause a cardiac stroke, which is what is called a heart attack. So CAD is coronary artery disease. All right, not a big deal. So let's go for it. So AD, we found it to be 3p, isn't it? Times, we found AD to be 3p, right? And then this one is this complex thing here, which is 3p. So this is 3p into cos x plus sine x all over root 2 sine x. Now this is times sine sine 45 degrees. Let's just put it there. That was 45 degrees, was it not? Yeah, it was. So guys, we just substitute here. This is a matter of substituting. This is half into 3 times p, which they told us is what now? P is what? 10. So this is 3 times 10 times 3 into 10 into cos x was 110. Oof. Yeah, forgive me there, guys. It's a bit silly now. It's a bit silly. 110 degrees. All of this over square root of 2 times sine of 110 degrees. That times by sine of 45 degrees. So yeah, I've lost time there. So let's just do that area all together. It's gonna be complicated. So I think it's always safer to start with the complicated side. So fraction button. We have 30 here. In fact, 3 times 10 is 30, man. Just simplify your life a little bit. It's going to be 30. So we've got here 30 into sine of 110. No, that's cos. 30 into cos 110 plus sine of 110. And then we close there. We're going to say here over the square root of 2 times sine of 110. There's room for errors here, okay? Please pay absolute attention, okay? We get that answer here, which is whatever that will come out. I will trust it's correct. So I'm getting 13,49. I'm going to multiply that answer with sine of 45, which is 1 over root 2. Then I'm getting a 9 comma whatever. Then that one I'm going to multiply with 15, because half of 30 is 15, isn't it? So I'm going to multiply this one with 15. So what I'm getting here, guys, is 143 comma 11 square units. So did they say x or p was some? Yeah, they just said p is equal to 10. They didn't say 10 meters. If it was 10 meters, we're going to say 10 meters squared. All right, there you are. So guys, this is complicated. I'm not going to go about marks at all here, because this is a simple question, but the only nasty thing is there's too many things in there. So I think here setting up an area rule is what is important, probably, and correct substitution into a complicated formula, not there but here, and then getting the answer. So that's how you get your 3 marks. Easy. Now let's get to the fun part. I'll try, guys, not to go beyond say I'm not going beyond 4 hours on this one. It's a bit long. Now Euclidean geometry is very easy. Okay, not easy, but it's very interesting. Now in the diagram, O is the center of the circle, so that's fine. We can see that. And M and P are you can see there, this is this quadrilateral there. It has all vertices in there. At the circumference of a circle, so that makes it a quadrilateral, a cyclic quad, even if they didn't say it. And then Sn is a diameter. I think it's important to note that Sn is a diameter of the circle, okay? So you know what is the story about diameters and circles? You know that in totality it subtends 90 degrees. This is not good, man. That's better. So you know that if this is a diameter, it should subtend 90 degrees at circumference. So that means M1 and 2 must be, yeah, boy, you understand. So always interpret things, man, when you can. And then we are told here chord MS and radius OR are drawn. So M2 is 64 degrees. So that's fine. We can see it. It's drawn into our diagram. So let's work out some questions here. Look, you can say a lot of things. I mean, if you look at this one, you can already tell that O1 is twice angle M1. But angle M1 is 90 degrees minus 64. And you can say O2 is twice angle 64. Angle at center equals twice angle at circumference. Same story as that one. So again, you can calculate angle P by saying 180 minus 64 because opposite angles of a cyclic quad are supplementary. So I'm sorry guys, I'm going to be a little bit silly and fast in this instance because we've lost a lot of time. We've lost a lot of time with the others, but I just wanted to be a little bit more elaborate because I know I may not be here as often as you may need me this year. There's a project I'm going into, personal adventure, so to uplift my level of service, so it's gonna be a problem. So we know that angle P plus angle M2 I don't know what I'm writing there. Okay, let me not be too fast because I'm going to make errors now. Is equal to 180 degrees. So what is the story here? We know that angles of cyclic quad, not angles but opposite angles. So let's just refresh this one. These are opposite angles of cyclic quad. They are supplementary. So this implies that now P is going to be 180 degrees minus 64 degrees, which is what? 180 minus 64. So look guys, even if you see time is really running away from you, do not hurry up such that you become erratic. You're probably rushing for what you are not gonna get right anyway, so don't make that mistake. I can see it's happening right now with me. So that is it. So this is how you get your 2 marks: statement and its reason and the answer usually. So let's do 8.1.2. So 8.1.2, we want M1. So M1, we can see that it is built from that angle being 90 degrees. So let's start by saying angle M1 plus angle M2, they are equal to 90 degrees. What is that? These are angle subtended by diameter. What is that? It was SON, sun. Okay, angle subtended by Sunday is that one, Therefore, angle M1 is going to be 90 degrees minus 64 degrees. So do you see when you just do a bit of a check there, you can actually cruise a bit. These questions are usually easy. You will hardly find them difficult at all. So this is where in Euclidean geometry, if you don't get these ones right, then you know you are very hopeless in this section of maths. Okay, just know it. If you can't answer this first question in Euclidean geometry and get full marks, just know you're not for Euclidean geometry. That one is a showcase. It's not even condescending, it's just the reality. So we're looking for O1. So we saw that O1 is going to be twice M1. Angle at center equals to twice angle at circumference for the same arc, which is SR. So sometimes it could be a chord. So we can just simply say here O1 is equal to 2 times angle M1. Okay, always make this statement so that they make sense. So you can say angle center equal to 2 times angle at circle or circumference. So you can write like that. Those are notations that are acceptable. This is going to be 2 times 26 degrees, which is 52 degrees. Okay, like I said, you can see here, you can answer this under 5 minutes. So these are some of the things when you feel tired from answering tough questions. In between the big ones, you can answer this. Okay, you don't have to start answering from question 1 to the last. When you're seeing that analytical geometry boxed you a bit, you jump to this one because you know this one doesn't need you to think too hard. Then you go back to the ones that can stall you. That's how again you gain confidence. That's how again you regain your momentum. That's how again you even save time, so that when you are really struggling, you only get boxed by big things, not small things. Yeah, boy. Okay guys, that is sorted. Full marks there. Again, statement and answer. I'm sure it is like that. So easy 6 marks there. Okay, it's not complete. There's an 8.25. Okay, so okay, this one will demand that I shrink my screen a bit so that we can see what we're working with. Okay, it's a bit technical right now. All right, so let's see here. 8.2 says in the diagram ABG is drawn. Okay, ABG is drawn, triangle ABG, okay, and E are midpoints of AB, and they're indicated, and AG respectively. So once you see a triangle where you've got this setup, it means this side or that line is parallel to the base. It's not just parallel, but it's equal to half that base. What is that theorem? It's called midpoint theorem of triangles. Ne? It's not midpoint theorem of other things. Midpoint theorem of triangles. Okay, so we already know that DE is half BG and they are parallel because that line joins midpoints of the two opposite sides of a triangle. I think this is proven in grade 10 or grade 9 even. It's not even a theorem that is, from grade 10 upward. I think it's grade 9. If not grade 9, it's going to be grade 10. So you can see you need all of these things. Anyway, let's keep going. D and E are midpoints of AG and BG are produced to C. So we needed to know that this is a straight line all the way to C and that. Okay, they're produced to, what is that? AG and BG. Okay, are produced to C and H respectively. Okay, that's fine. So that can be an exterior angle there and so forth. Okay, F is a point on BC such that FG is parallel to, again, if you're looking at this triangle over here, you can tell that proportionality theorem comes into the fore, as well as that one with the midpoint theorem. Okay, so we've established here that our midpoint theorem will come into our rescue, and it gives us an area for proportionality theorem. So that's what we are dealing with here. All right, guys, not too much to interpret here, more to work. Now it says give a reason why DE is parallel to BH. You already saw. I told you. Wait a minute. That's not what. Yeah, BH is the same thing as BG. In that triangle, it's midpoint theorem. So that's what you're going to say. So not too much to say here. Okay, maybe let's just answer 8.2.1 right here so we can go back now. I don't even remember. What was the status of this thingy? It doesn't matter anyway. So we know that it's midpoint theorem, right? So we can just simply say DE is parallel to BH due to midpoint theorem of triangles. You can even say that this is applicable to triangles, not other things. Please don't do it. It's dangerous. So you get your 1 mark. So easy, 1 mark right there. So we've got icon. That is too much. 8.2.2. I know, guys, I may not make it to 4 hours, but yeah, if I was not explaining, but I can't just do this thing. Why would I do a video if I'm just gonna write answers? It's pointless, isn't it? My mission, I'm sorry, guys, I'm just talking too much, but I just have to. My mission, guys, is to help you understand even the most cumbersome areas of maths, okay? As you could see, some of the problems kind of threw us off, but we found our way by just revising a bit of things. I mean, these are things you know, but you don't think about. This is very good for me because it helps me portray exactly what I'm trying to show you, that everything is connected, no matter how very small is that connection. It may just be the link to the answer, and in the quickest way. So I wanted to make sure, guys, I push the limits a bit so that even those who teach you, I know they sometimes bump into these videos, maybe by being referred by one of you guys who probably sees something interesting and then you want your teacher to have a look and maybe share an opinion of it. They do sometimes bump into this. So I knew that I'm doing this to also stimulate some of those who are already good to even become perfect, okay? Because at the end of the day, the better they get, because they have a lot of you looking up to them, then you will get even the very best out of them. At the end of the day, we want our country to be lifted. This is purely to try and fix our country from the ground up. We can't fix the old ones. We can't fix people already up there. You are the only gold that if we just make sure it's processed right, it's going to be of a very high price and value for our nation. So guys, this is not a popularity contest for me. Just know that. This is just for me to throw something back to making our country as best as possible. Of course, it's going to be small steps. It's not everyone who's going to see my videos. It's not everyone who's going to learn a thing or two from them. But at the end of the day, you will somehow find the very best because of these videos, okay? I'm joking, guys. Listen to me elevating myself beyond my level. I belong right there at the bottom, okay? Don't worry about it, but I've said what I said anyway. It's not gonna come back to my mouth, isn't it? But trust me, guys, this is not arrogance. This is not overly projecting myself, but this is essentially my deep-seated desire to contribute something to making our country better from the ground up, because those who are already up there are impossible to change. They are almost impossible. We can change them, but they are almost impossible to change. It takes a lot of effort for very small gains, But with you guys, a small effort, it comes with big gains, which is exactly what we want. You are the best investment. The older ones are not a very good investment option. Anyway, let's move. Okay, guys, I think we've done it. So they're saying it is further given that FC over BF. So let's look at that line. Where is FC? FC is this line right here. Over BF, which is this line right here. They're giving us the ratio is 1:4. So FC, we can make it X. This one is going to be 4X, okay? Just know how to do this. This question is always there, okay? It's been there since around 2012 or so. So there's lots of videos I've done where you can learn how to play with these kind of diagrams, because you normally are not given circles, so it makes it a bit harder. And then DE is 3x minus 1. Where is that? So this guy right here is 3x minus 1, okay? DE. GH is x plus 1, so it's fine. We're going to just put them there and then calculate giving regions the value of x, okay? Easy. Easy. So you know what, guys, you can already tell that when we set up the proportionality theorems here, the first one is just helping us to find the fact that this line is parallel to that, but not just parallel. we know that this line is half this one, meaning this line is twice that one. So we can simply say this is basically 2 into 3x minus 1, midpoint theorem. So we already have this. So now once we have this, we move and gravitate into this triangle here. Now we use our proportionality theorem here to set up this ratio over that one is going to be equal to that ratio over that. Easy. But first, we need to explain why that is. The rest is already given. So let's go on and attack this question. It's not too difficult. So let's say BG, okay? BG. Or we can even say DE. Yeah. Let's just say BG because that's what we're interested in. So we can just simply say BG is equal to 2 times DE. That is midpoint theorem of triangles. That is essentially the best way you can put it. Or you can say DE is parallel to that, but I mean, you will have to also capture the fact that it's the midpoint. So midpoint theorem says everything. It says this line is parallel to that, and that line is half the length of that line. So if you said midpoint theorem, you are in a good position. So this is going to be 2 into 3x minus 1, which is going to be 6x minus 2. So that is easy, guys, not a big deal. So we've sorted that one. Now once we've sorted this one, we can say now in triangle. What triangle are we looking at? CB or BCH. Let's just go alphabetically. Say BCH. What in that triangle? We know that we can simply say BG over GH. Okay? You can say BG over GH is going to be in the same proportion as BF over FC. Okay, what is that? This is prop theorem. Always take the set of parallel lines that we're given. We're given that GF is parallel to CH. Okay, so when you do the proportionality theorem, you mention the set of parallel lines. Now this implies that BG, we found out that it's going to be 6x minus 2 over. Now what is GH? GH is x plus 1. Okay, let's put them in brackets because those are terms. Now the next one, we know that this is going to be essentially, maybe let's not use x then, because when we use x it becomes a bit silly. Since there's a lot of x's there, let's not use x as the variable. Let's just choose a. Don't worry about this being a. It's not going to cause any trouble. So this is 4a over 4a over what? Over a. Okay. So remember a cancels a. So this implies that if we cross multiply here, we're going to have here, this is 1. Remember this is 1. So we're just going to have 6x minus 2 is equal to, when you multiply this by 4, it becomes 4x plus 4. Easy stuff. Then you move the variables to one side. It's going to be 6x minus 4x equals 4 plus 1. Now, therefore, we know that our x here, remember this is going to be 2x is equal to 5 over 2. Easy. Easy, guys. You don't want to prolong this as well. So how many marks here? 6 marks. So that was an easy 6 marks, to be honest. But maybe this is a critical step. That is a critical step. Correct substitution and some gymnastics. And the answer, how many marks here? 1, 2, 3, 4. Where are the other 2 marks, guys? Well, for performing this gymnastic here of cancelling things out, I think it's important. maybe the gymnastic of cross multiplication. I mean, guys, this is ridiculous. Maybe that statement is important. Why did I forget? 1 2 3 1 2 1 2 3 4 5 6. Yeah, that is it. That's how you get those 6 marks. Okay, now you've got a proof here, guys, which I really don't like. Okay, I really do not like this one. How many questions here? Well, let's move. We are chasing for hours here. But my main reason for taking a bit longer, guys, is to help you review this. You already are not against time at this point. So sometimes when learning has to be done, it just has to be done. So first, when you're given this, you are proving that OD is perpendicular to AB. Now, we know that a line from center to midpoint of a chord is perpendicular to the chord. We want to prove that. So that's theorem 1, grade 11. I don't know if I should really waste time. Let me just point out what you need to do before I just waste enough time here. Now, what you need to do here, guys, is very easy. You're just going to prove congruency. First of all, we know that this line, the construction you're going to do here is just going to say join AO and OB. Then you're going to say in your proof, this is equal to that. This is the common side. Okay? This one was given AD is equal to that. So therefore, these are congruent triangles. Side, 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 side. But now because these are on a straight line, ADB. So you're going to say that angle plus that must be equal to 1/8. Angles on a straight line. Therefore, you divide by 2. You will be able to find that each one is 90 degrees because they are actually equal because of corresponding angles in congruent triangles. So that one is theorem 1. Please go and learn that one. I cannot overly say this one. Now in the diagram, we know that E, B, F, S, and P are points in the circle centered at O. So I don't know what happened here. Okay, I probably cut information. So I was wondering, where is this going to? Sorry guys, I'm not going to waste time doing the proof. It's in your textbooks. Ne? I've already pointed out what you need to do. Let's rush. We don't want to waste time. In the diagram, E, B, F, S, and P are points on the circle centered at O. Now, all of these points, 1, 2, 3, 4, 5, that's what we call concyclic points. Concyclic meaning they are at the circumference of the circle. Of course, if you form any quadrilaterals with any combination of those points, that becomes a cyclic quad, all right? Okay, that's fine. That's the information being projected to us here. GB is a tangent. So GB is a tangent to the circle at B. So what do we know about tangents? Well, first of all, tangent is perpendicular to radius. We can already see that OB is the radius, so there must be some 90 degrees there. Yeah, you are very correct. You are correct. Now we can't really see the 10 chord theorem. It's not there, so we just forget about it. It doesn't come out nicely here. It's not here at all. Now FE, okay. So FE is produced to meet the tangent at G. So when we say FE is produced, it means it's the same straight line. Because if that is not given, it means this may be angulated even, so you cannot assume. I didn't like the prelim questions on paper 2 from Gauteng because they didn't say some information, some pieces of information, so you had to assume that it is so, and that's not quite correct. OT is drawn, okay? There is OT such that, T is the midpoint of, again, you know very well, guys, that if a line is drawn from center and it goes to the midpoint of a chord, what is that line? That line is perpendicular to the chord. This is exactly this theorem you just proved above over there. So now what do you see, guys? Once you see a bow tie already, a bow tie from the same line segment, sort of, even if there's no circle drawn, Once you see a bow tie like that, such that those angles are equal, it means this BTOG is a cyclic quad, okay? So you already know that you are already looking at a cyclic quad by just interpreting those statements, and you may find a question asking that. So once they do, you are already in a good position because you already primed yourself. Okay, now I think we're done. GOA drawn, okay, BS is drawn such that this is parallel. Okay, I think the next piece of information that is important is this one. When these two lines are parallel, what does that mean? It means, and only means, that that angle there, which is, okay, let's not say too much, but let's just look at some options just to simplify our lives in case we need to. We know that this angle here is going to be equal to that angle. So this is a bit complicated, okay? Just forget this line that is crossing, but that angle is equal to that angle. Why? Because this becomes a transversal line. It's a chord. So these are corresponding angles, and this angle is also equal to that. It is vertically opposite that angle, or it alternates with this one. These are alternate angles. So these are some of the things, folks, that you make sure you put down, because now you will start cruising. Question says, prove giving reasons that OTBG, you see, OTBG, you already saw it, you already thought about it. Now when you see these 5 marks, like piece of cake, because I've already done half the work, rather than to start reading here and then getting frustrated as to why it is so. So you see, the method is read the statements, interpret them, think about some things that you know. That makes that 5 marks, a given. But it would not be such a given if you started here. Because if you started here, you would be struggling to find the links. You would waste time. Alright guys, I think we are really wasting time anyway. So let's continue writing. Alright, so guys, it's not a big deal. So let's first, we know that for this OGD whatever thing to be, now it's going to be the converse of the opposite segment. I mean angles in the same segment, because we'll start by naming them and that they are equal. Then we know that is a converse, because the actual theorem is when it is given that this is a cyclic quad. Okay. First of all, we're going to say now OBG. Now OBG is equal to 90 degrees. What is the theorem, or at least a corollary? We know that the radius is always perpendicular to the tangent, or you can just say tangent is perpendicular to radius. You don't have to name which one. If you already named it, they will understand that we're talking about OB being the radius and GB being the tangent. Alright, so we can say also what, mister? We know that OTG is equal to 90 degrees as well. So what is that? It's line from center to midpoint of chord. Right. So those are valid statements to say. So you already have 2 marks there already. So what are you going to say? You can say therefore OBG is equal to OTG. Okay, easy, because you can see each one is equal to 90 degrees. You can say therefore, if those two angles are equal, that's a bow tie. Those are angles in the same segment subtended by GO. So you can say therefore OTBG is a cyclic quad. Now you have to provide the reason. It's the converse of angles in same segment. Okay, or you can just say angles in the same segment proved equal. You don't really have to say converse. So that's it. If you say they're in the same segment, you'll have to mention that G O or OG is your, not your, but is there. is the what you call yeah, the chord. But if you said converse of angles in the same segment, they already can understand this. I mean, sometimes it's a bit cumbersome. So friends, I would award you 2 marks here to just make up for the 5 marks, because it's just as simple as that, unless there's something else, sorry, that demands marks. So you see how easy this was. You answered it in 3 minutes time. Okay, maybe I'm overestimating my time or underestimating my time, I don't know, but it's fine. Let's just keep going. We're almost done. GOB is equal to S. Okay, how is that true? Where is GOB? GOB, meaning this angle right here. So we are told here to explore that this angle right here, GOB, is equal to angle S, which is this one right here. Okay, so how are these equal? How are these equal? So I'm overlying it so that I'm not immediately saying they are. The answer is, we know that if we proved this is a cyclic quad, that angle is in the same segment with this angle over there. So literally, that angle is now equal to that. Now that we know this is a cyclic quad, angles in the same segment, subtended by chord GB this time. But we saw that this one is corresponding to that, so that is how they are linked. So you see how easy this becomes. Again, you see these 4 marks is a piece of cake when you analyze your diagrams and already interpret with the knowledge that you are supposed to possess by the time you sit for your finals 2022. So, sorry, 9.2.2. First of all, we're going to say that GOB, this very same angle, is equal to angle GTB. Okay. So what is that? Angles in same segment of cyclic quad. Maybe just say cyclic quad in, you don't have to mention 9.2.1. So now you are becoming a bit more confident, maybe overconfident to this at this level, because they're like, what are you trying to do, man? You're trying to show them something. Now you have some situation there. But what, mister? Or what, ma'am? But I'm not a ma'am, I'm a mister. So what, mister? Well, there is a serious part. I know that GTB is actually equal to angle S1. What is that? These are corresponding angles. And you name the parallel pairs. What was given to be parallel is PS is parallel to GF. Ne. Yeah. That was given information. Now you can say, therefore, it comes out that GOB is actually equal to angle S1, because each one, can just say each equals angle GTB. You don't really need this reason. I mean, you can almost tell that there is a link there, so there's no stories to tell. So do you see how easy that proof was, guys? So, but if you didn't know, you started by reading here, I'm telling you, it looks a little bit difficult. But when you read statements, you just take a bit of a pause, interpret a bit, try to remember things, how they may look, and try to interpret eventually what you saw. This just tells you, when you come to these questions that ask you those questions, you already know what is happening. So you just simply write the logic that links them, which is just transcribing what you already read, or at least read through the question. Sorry guys, I'm becoming a little bit too excited. Now I'm all over the show. So again, you get a mark, guys. You get a mark too. This one is a serious mark, a very serious mark. So I don't know, guys. Yay, man. Maybe we can give you 2 marks at the end or 2 marks anywhere. Doesn't really matter. I don't know why. Surely they should be giving you 3 marks here because there's 2 things to link, but maybe there's a method that they thought of which is a bit longer. I'm not gonna even explore that at this point. Time is not on our side. So guys, we've sorted this question. We've scored total there. Now let's get to this one and box the last one quickly. Let's not go beyond 15 minutes answering these questions. So I hope it's not gonna be a rough ride. Now let's get our pens ready to interpret. Now we're told you in the diagram PQRS is a cyclic quad. Again, this is just a giveaway because I'm in PQRS. You can see the vertices are at circumference. So I always am not happy when they give that away because you need to give a student a bit of a difficult time, okay? Figuring things out. This is an exam. This is a test, guys. It's not a place where you're just going to be donated marks to. Not for donations here. It's either you take it or you leave it. Thank you very much. Now, KP is a tangent. Okay, this guy over here is a tangent to the circle at P. Now, once you hear that word, you immediately start thinking, what information about tangents do you know? You know that that angle P1, the angle between the tangent and the chord, which is PS, is going to be equal to the angle subtended by that chord at circumference, or the angle in the alternate segment, because this is one segment or minor sector. This is the major sector or the alternate sector. I mean, there's plenty of ways to picture this, all right? Right. Now, that is fine. Great stuff. I mean, from looking at the diagram, you can already tell that that angle is equal to this one, right? Corresponding angles. And if this angle is equal to that, it means this DC, there's a circle going around there. There's another circle there, which shares a common tangent, P. So you may find yourself asked a question like that. So already, when you're starting to interpret things, a lot of revelations come. They make light work of those questions that you're going to come across normally. So please, if you ever want to crack Euclidean geometry, this method, I can tell you, it's bulletproof. In fact, even if you miss out some marks because some questions are just higher order despite any understanding whatsoever, but you will not walk away with a 0. That one I can assure you. You'll just get stuck somewhere. That's it. Anyway, enough of trying to convince you. You are not convincible otherwise. I know it. So again, guys, look at this. If this is this angle is equal to that, isn't it? You know that. Why is it equal to that? Angles in the same segment subtended by chord SP. But we were given, before we colored anything, just look, this angle was made to be equal to that. So this angle now eventually is also equal to that, meaning this line bisects this angle SRQ, and that can also be a potential question. So you see, all those links come from that. So you could already answer a lot of questions that could potentially come. Now let's just read on. Okay, we've exhausted a bit of that analysis there. So now we're told here, C and D are points and on chords PQ and PS respectively, and CD is produced means straight line, to meet RS produced at A. Okay, so all it means, these are straight lines, continuations of whatever. So meaning this is a triangle, it's not something else like a quadrilateral. Okay, now we're told here CA is parallel to QS. Okay, that is important. CA, California, Cape Town, whatever, is parallel to QS. I don't know what QS is. Okay, so there it is. Now this is why we knew that this would be equal to that. Okay, fine. And the same thing, this angle right there is going to be equal to that angle over there. So there's a lot of things you can see. And then in this big triangle, let me just outline it with maybe this color. So if you look at this triangle right here, So if you look at that triangle, you will already see that proportionality theorem is coming back, because if you have one side parallel to the third side of a triangle, it cuts the opposite sides into equal proportions. And that also applies for this triangle right here, but I'm not going to show you that SPQ, because this side is also parallel to the third side, so you will have a proportionality theorem. So, but don't overly color your diagram, because you'll end up rubbing off important information. Okay, P1 is equal to R2, so that's the one that we looked at, so that is important. That's an important statement. So we've already interpreted it by just looking at the diagram. Okay, guys, now you are ready to flex some muscles here. So this helps you to gather your thoughts, get a revelation of a few things. It makes it easy to deal with some higher order questions. Remember, there will always be a higher order question on Euclidean geometry that will cause you pain. Even anyone who tries to show you how to solve that, the first attempt is always painful. Okay, it's not easy. But for me, because I don't really care for difficult things, I love difficult things. I actually hate easy things. You know why? Because anyone can do those things. But tough things, they make me feel a little bit special, because I can do things that others cannot do. So if you're like me, then good. But don't be arrogant, please. If you get to be that good, don't be arrogant. Don't undermine people. Don't undermine anybody, even your teachers. When they miss a point, it doesn't mean you know better than them. It just means you saw it quicker than they could. You understood it faster than they could, but you're not better. What they know, you would never put together in one day. It's something you're going to learn as you grow. So please maintain your humbleness, no matter what your state of mind be, whether you're brilliant or not. Remain humble. That's what I always try. But in any case, I never feel that I'm better than anybody. So I'm always a sinner, or someone who keeps trying. Just keeps trying until I can measure up to the best. That's all I see myself as. I'm someone who can actually rise up to the level of the best. But even when I got to that level, there will still be somebody or some group of people better than that level. And I'll attempt to get past that level to get to the next level. And so on and so on. Until I die. I'll keep trying. The brain never gets tired of it. You only waste it by not using it. By overly indulging on things that are already ready-made, then your brain starts shutting down some departments. As you would know, for the sakes of costs, if a department is useless, you close it. That's how your brain works. If you don't use your brain to its full capacity, it starts shutting down. Memory starts becoming poor. Logic starts becoming a little bit fuzzy. Creativity starts disappearing. At the end of the day, you'll be someone who totally depends on others, and that's very sad. So don't allow yourself to be like that, ne? Not when you've come in contact with me. I am almost, not totally independent. I am almost independent, meaning I can function even if I'm all alone. Of course, with difficulty, but I can pull the weights. So you must be able to do that as well. Okay, guys, let's finish this long road to freedom. I'm sure you guys are angry with me if you're watching this video, because you'll be like, this guy wastes so much time talking crap. Question says, let's find S1 to be equal to T2. How is that possible now? Now you see they're hitting you with a question that even if you have done all your gymnastics right here, all your routines, you just warmed up. You didn't do anything, because this one, it's 4 marks, yes, but do you see? Now T2 is not even an angle you can link to that directly at this point. So this angle, how will it be equal to S1? Like, what is that? Now that is how painful this thing gets, okay? It gets a lot more painful. So this is not an easy question. Okay, guys. Now we need to plan our attack. Now, once you cannot find angles that link to that directly, now you have to do an indirect link. That is why it is a higher order question. Now we need to find an indirect link. But if you're looking at S1, what is S1 in this diagram? It's actually an angle. That is an exterior angle of this cyclic quad that they gave us. So that piece of information has to tell you and I that S1 is basically Q1 and Q2 put together. What is the reason? Exterior angle of a cyclic quad. So do you see all of our linking? But we could have seen this one if we went a bit deeper, but you don't want to overly interpret your diagram because you're going to end up wasting time. So some of them, please remember that whatever interpretation you've done is not enough, okay? But it's just, okay, let's not say it's not enough, but it's not absolute, as in it's not complete. You may still have to discover more, like this one. So that's an exterior angle. So meaning S1 is basically the sum of Q1 and Q2. But we discovered that Q2 is also equal to R2. Okay. So now this is effectively saying that R2 plus Q1 is effectively equal to that. If we just, plus, what is this? We can say R2 plus Q2 because R2 is effectively Q1. So this plus that is equal to that. Ne? However silly this looks, but that's what it is. But what is the sum of this angle and that angle anyway? It is equal to that angle because this is an exterior angle of this triangle RTQ. So these are some of the questions that will horrify you when you see them because you see here it's a bit technical. So they will always bring out this one. So let's start. So we know that S1 is equal to, we saw that it's going to be Q1 plus Q2, right? Great. What is that? We saw that this is an exterior angle of cyclic quad. At least they gave us one cyclic quad, so we're not going to explain this. All right, so now what is next? The story that is next is to say, but, what are you trying to get to? We know that, look man, Q1 is equal to angle P1. What is that? This is tan chord theorem, okay? Because this is the angle between the tangent and the chord, it will be equal to the angle subtended by that chord. So we know that this is tan chord theorem, okay? Not a problem. So effectively, what are we also looking to combine, guys? See now, we are combining P1 and Q1. We can say also, look also, now this one is a bit cumbersome, I'm telling you. Actually, we don't need to say also. All we can say here is to say therefore. Yeah, that one is important. We can say therefore. Maybe we should have started here. I think this is important that we started here. Let's reverse our order of statements because it looks a bit silly now. When that one is, I suga wena man. Sikanixwayela. Nitakuxaya. Utanitwa kahle. Eish. Mina ni vulavula Xitsonga and wa swi tiva hi ku ri Xitsonga hi xilungu man hi wena u tlanketsana o ka se nkitsisilo man. Yeah, that's what I thought. You ain't gonna do nothing on me. All right, let's not do anything. So guys, we needed to conclude here that since we were given that P1 is equal to that angle here, R2, so we can just simply say therefore Q1 is equal to R2 because we can see we want to link R2 and Q1, because that helps us a lot. All right, so that is the conclusion we're trying to arrive at. Okay, it's important, but you see it looks almost disconnected. Then this statement is our beginning statement. So now what can you see here? We can actually replace Q1 with R2. So we know that this is basically R2 plus Q2. Because Q2 is this angle inside this triangle, so we maintain it because it's important. Again, everyone knows that once you're putting R2 in the space of Q1, it's because you've set it above. That's fine. Now you can say here, since we've had, okay, maybe the but here is not important anymore. The but is important right now. We can say but, what is it, mister? We know that the angle that we're looking for, T2, is also equal to angle R2 plus angle Q2. What is that? Exterior angle of triangle. Now we didn't mention any triangle, so we're going to name the triangle RTQ. Okay, please. Once you speak of a triangle that you have not named, now is the time to name it, or else you're going down. You're going down by the head, okay? Now look at this, guys. What is that? What is that? What is that? What is that? RQ plus Q2, R2 plus Q2. So this eventually concludes that S1 is equal to T2. Okay, done. You can even write a reason, say each is equal to R2 plus Q2. That's if you're not convinced, because at times they'll be like, yeah, you're saying a lot of things, but I think this question deserves 5 marks than 4 actually. But there may be an approach to it that is essentially important. So I think the key here is to get to this one. So that 10 chord theorem may not really be a very good mark, but this one is technically important. So we've got 2 marks already there, and essentially this one is also an important statement, and then the final answer. But again, they said prove that this is the case. So if you link them, you may not necessarily get a mark here, but you may actually get a mark here instead. You know? So maybe 4 marks is fine. Okay, I became a bit overzealous. No problem. Next question, 10.2. Okay, guys, let's finish this thing before we take forever now. Now we're finding a bit of a situation now. AD over AR. So I'm just going to play with this. So guys, when you get this, please don't try to look for triangles at first. Just look for those lengths. Where's AD? AD, where is it? Let's look for AD. So AD is this length over here. So first of all, don't even think about other things here. First step, you analyze what is given so that it can give you a direction as to where you must go. Otherwise, you can't just imagine you must be there. Now, the next one is AR. We want AR. Maybe we already put something. Yeah, this one is going to be a bit challenging. So let's do this. Let's find another color for AR so that we don't have a clash of things. So I'm sorry for this, guys. Now let's look for AR. Where is AR? AR is that side. So AR is that side. So do you see now? Just these two are enough to make you aware of where you're going. Can you see this side belongs to this triangle? Or it's a segment of this whole side of this big triangle, and you can see that side is that whole. So this gives you a clue that you're dealing with this big triangle and possibly this small one. Okay, that is the idea. So let's look at AS. Oh, right. Okay. All right. So we already used you, sir. I don't know what we're going to use. Do we have enough colors here? I got blue, man. Blue pale. How? Ke batla di-color banna. Scantain. Doesn't really give me what I want. Okay, guys, it's fine. We're just gonna be strategic. We're going to be strategic. I'm always a guy with a plan. So let's see. Now, where is AS? So if you're looking at AS is now this side. So do you see now? We have AD, AS. So we can't have these two sides if we're not talking about this triangle, the small one. And then let's see, what is this one? AC. Do you see AC is also this side right here? So there's no way we can talk about two sides of two triangles if we're not referring to these triangles. So it's that big one, AR. So this tells you that you're going to first look for for similarity, because we know that similar triangles will have their sides dividing into the same proportion. So do you see, when you analyze this thing and look for those sides, you already can map out which triangles to look for instead of trying to figure out without really putting any sense into it. You end up struggling, because someone may want to use this proportionality theorem here. It's not going to help at this point, but you need to prove similarity first so we can safely land our thingy here. So it's going to be in triangle. Now we're going to use the big one because the small one, because they started with the side of the small one, AD. So we're going to say ASD or ADS. Let's just say ADS. I really don't pay any particular attention to how I name these. For me, it is almost insignificant. I'll show you why. The other thing is we are looking at the big one, which is ACR. Okay, I really don't care again as to why I'm writing them, because I know that when I'm looking for proportionality, I'm looking for sides opposite angles that are equal in these triangles. So, but you may not like that. You may just want to make sure that you put them such that everything is in order. It's okay, not a big deal. Okay, now let's start, guys. We know that angle, this angle over here is common, isn't it? Angle A is a common angle. Angle A is common, number one. Two, what can we say? We can actually say, hey, look at this thing here. I thought I knew where I'm going, but now I am already in trouble. Okay, look, I already know that this angle is equal to that angle there. Ne? Yeah, but what else is equal to that angle? So that was a bit of a discovery. So again, it makes life a bit easier though. If that angle is equal to that angle as well. Why? Remember, these are alternate angles. That's the letter Z for Zama, my name. Ne? So there you are. So this angle, we proved that this angle is equal to that. So it comes in to our rescue here, but it's going to be a bit longer. So what we're going to try and say, we're going to say S1 is equal to that angle. And then we have our part. That one is given above. So S1 is equal to T2. Okay. Now this is a general statement. We can say S1 is equal to angle T2. That was proved above. Okay. Now we can say, but what is the part now? We know that T2 is equal to what angle? Angle C2. Now what is that? This is now alternate angles. Set of parallel lines. What was given as parallel is CA parallel to QS. Okay, so now we can make a conclusion and say therefore S1 is equal to C2. See, that angle belongs to the small, that angle belongs to the big one. So that is those angles we were trying to link. So please guys, be logical and have a systematic approach. Don't be haphazard. Now, once we prove two pairs to be equal, we don't have to try and link this one to that. It is automatic. So D1. Just a sec. Okay guys, I just needed to charge my phone. I think the battery was quickly running low. So yeah, let's see now. So we've done this link. So we can say therefore, we don't have to even think about it. What in this, what is therefore now? We can say therefore D1 of the small triangle. I like it when they have these little subscripts. Is going to be equal to R1. Oh, R1. The thunya tsa masole ntate. The R1. Hona le mangae wa binang he. Haye mona o mahaye mona re. Di R1. Di R1. Di thunya. He tsa masole di R1. Di R1. Hey, emanyana, we're not Lordina. All right, what is that? These are, you can just say remaining angles. Or you can say sum of angles of whatever. This one is easy. But to say remaining angles is a bit more convincing. Now, therefore, triangle ADS is similar to triangle. What was that? ACR. Okay. Now, what is the reason? Always provide the reason. Don't forget it. Angle, angle, angle. Or you can write a word, equiangular. So this implies, yeah, doch. Now, what does this imply? Remember now, we want to find this. So we start with AD. This implies that AD over. Now, if you look at AD, AD is this side of this small triangle, this side, but it is opposite which angle? Angle S1. Okay, this AD is opposite S1. But S1 in the big triangle is equal to that, what you call, is equal to C2. Okay, we start from C2. But the side opposite C2 is AR. So you're going to say AD over AR. Yes, 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 yes. You see how cool this is. So you don't really need to put them in a particular order. Just know how to link these two. Now we're starting with AS on the small triangle. So it can be any side we choose. So we're going to say AS. That makes our life easy. But now AS is opposite which angle? AS is opposite that angle there, which is D1. But we just found out that D1 is equal to that angle R1 on the big triangle. And then the side opposite R1 on the big triangle is AC. Isn't it what they want from us? That's exactly what they want. So we can say AC. The reason now, these are proportional sides in similar triangles. Remember, this is under the same umbrella statement that we're talking about those triangles. So this is it, guys. So this one is a bit of a technical proof because it involves an intermediate step that you are only to discover for yourself. So, of course, there are some important statements that need to be said, but I think proving the similarity here is quite important. And of course, we can give you, I think this one is a good statement to award marks for. And then this one is also a good statement to award marks for, actually for the proof, for the reasons more than that, because it's already given. So 1, 2, 3, where do we get the 5th mark? Ooh, maybe this angle is important. 4th mark, that one is a key angle. The common angles, is for everyone to see, but that link, I guess, is important too. So maybe that's how you score those 5 marks. But please pay attention to the official marking guidelines. This is all arbitrary, but to try and show you key areas that are potential points where you get marks. It's not definite, but those are highly likely to give you marks. Okay, let's get our pens ready again. Now, last question, guys. I've been doing this for long now. Last question says, prove that AC. So look at AC. Again, don't try to see where this is coming from immediately, okay? Look at AC. Where is AC? Now, AC is this line over here. So it's still part of this triangle over here, so to speak. Now you look at SD. Now, where is SD? SD is actually this side over here, okay? So this side is of this small triangle because SD is here. Maybe let's just do this one. I know this diagram is already now a little bit buggered. Sorry, guys. But SD basically is this side over here. So don't mess your diagram up like that. So SD is here. So look, we're still talking about this triangle and that big triangle somewhat. So it means they are not gone from us. So we need to think about them as we continue solving. So we know that, okay, those are the sides of these very triangles we worked with. So they need to be considered somehow. Now let's continue exploring what this thing is trying to drive us into. Now we have AR. Where is AR? You can see AR is this side over here. It's the side of this big triangle there. So it's still these triangles, are they not? And then TC. So sometimes there is a bit of an odd one out. Okay, let's try and look for some other color. Which color haven't I used? Yo. When Scotland D now when TC. Okay, now I'm going to just go back to my black pen. Okay, guys, TC is now this side. So this is the odd one out. Okay, now this changes the game a bit. Now you see that literally all of these 3 sides, the first 3 sides, are in relation to the triangles that we worked with above. So largely we're going to be using that triangle. But now TC introduces a bit of a problem because now TC is just a portion of a side of this triangle. So what did we say? Initially, we saw that this triangle, we can actually look at it in terms of the proportionality theorem, right? Why? Because then if we do so, we know that this line is already given to us as parallel. This line is parallel to this one. So in this triangle, we know that this side and that side will give us the same proportion. But now we need to be smart about how we do things. Okay? We need to be very smart. We have an SD somewhere, which talks about the similarity of those other triangles, and then we have this one. But now let's try to do something that captures TC, for example. If we're looking at TC, now we're going to check this triangle in terms of the proportionality theorem. So we're going to say this side TC over the whole side of CR, okay? Let's see what that tells us when we say AS over that whole side over AR, okay? Let's see what we get. So we can start with this side AS if we like. It doesn't really matter where we start. What is this? This is 10.3. So getting an idea of where you're going, guys, is important. So we're going to say AS. let's just start with AS because we want to accommodate the TC. So AS over, we can say AR. Is that AR? Yeah, over the whole side. AR is going to be equal to, now we're going to see that TC comes in, or CT, which is computed tomogram or tomography. So CT scan of the brain. Oh, doch. You guys are going to be learning about those in radiology, and then we're going to say the whole side CR. Okay. CR. So what is that? This is prop theorem. Now we get those sides that are parallel. So we're going to say now TS. Okay, we're just going to zoom in into what we want now. We're going to say TS is parallel to, say, AC or CA. Let's just say CA. In triangle, let's name the triangle. That triangle is ACR. Okay, because we didn't say ACR. In fact, you could have written in triangle so and so that you don't have this complicated reason. Now guys, we just cross multiply. You know the gymnastics here are simple. So this tells us that therefore AS multiplied by CR is going to be equal to AR multiplied by CT. Holy Spirit, move in this place. So do you see we've gotten those two? There they are. Sometimes a little bit of planning. So there they are. So we already have the right hand side. Now the question is, who are you, say? Can we find you? Now we saw that when we analyzed these statements, they were largely in these triangles we proved similarity. So can we, by any chance, can we, by any chance, find something that would give us this? Because, I mean, now to answer this question, we need to find some sides in those triangles that are going to be equal to that thing. So our job now is to find some sides of these triangles that we spotted so that whatever it is equal to this thing. Ne? Because when this thing from that triangle is there, we will be able to, okay, what am I saying? Let me just think now. I'm starting to lie to you guys. Okay, look, this is the thing that makes us have a problem because we already have the right hand side. So we want this thing here, this one right here. Understand? AS multiplied by CR. Let's see what is AS. Do you see AS and CR? So these are the sides in these two big triangles and the small one. So we need to find something that is equal to that, which is going to be equal to that. Ne? Because once we find this thing, we can simply replace it here. Do you understand what I mean? We can replace this one here. So now we need to set up something that is going to give us this. But whatever this is, it must be equal to this one right here. AC times SD. So I don't know if you're hearing it or you're losing it, but now all we know is that we need this AC times SD to be equal to AS times CR. Because if we can find something that equates those two sides, we can effectively replace this one by that one so that we can prove the identity. So again, this is one of those questions where you won't get a very direct answer, but you just have to find it. So let's do. We can say, but sorry there, guys. You guys will forgive me for the time I wasted it, but this is fun, man, and it's nice to show others as well what you are discovering because they will too see exactly where it is. So these are the questions that, yeah, most of you guys who are not strong in maths, yeah, they would not even finish answering. Now let's think about it. We said, guys, our task now is to say, is it possible that we find that AC multiplied by ST is equal to this thing here? Is equal to this thing AS times CR. Because if we can find this thing to be equal to that, we simply replace this thing here. Here. We replace this one by that one that we are looking for. Hayi ke ngoku kwenzeka ntoni ngoku? Suniphaphela wena man. Suniphaphela. Ish. You know, you're spoiling my excitement. So guys, now this is our task. So you see sometimes these questions, yeah, you're not going to crack them easily. So now this is our task, because once we associate the two, we substitute one by the other. So now let's see. AC belongs to which triangle? The big one. So we can start by saying AC. Let's start by doing that. We can say but AC over. Now AC in this triangle is going to be over what? Is it CR or AS? Let's see. AC belonged to the big one. AC is opposite which angle? AC is opposite that angle in the big triangle, but that angle in the small triangle, that angle is equal to this angle in that one. So the side opposite that is AS. So we're going to say over AS. It's starting to play out right. It's going to be over AS. Is equal to. Now remember, we need to be strategic. We have AC over AS. So AC over AS. So we already have something here. Now, can we find CR? CR belongs to this big triangle. So CR is that side over there. So CR is opposite that angle. So let's start by writing CR. Because CR is driving us to where we are trying to go, over. Now CR, we said, in the big triangle is opposite which side? Sorry, CR is opposite that angle. And that angle, the side opposite that angle in the small triangle is ST. So it's going to be ST. So again, what are we going to say? Proportional sides in similar triangles. In which one? We proved similar triangles in 10.2. So you can just write the 10.2 to direct somebody. Now, of course, the gymnastic is to do that. AC times ST is equal to AS times CR. Look at that. Look at that. Do you see now that AS, do you see that this thing right here is the same as that? So we can simply say, therefore, if this thing is equal to that, we can take this and replace that one. So we can say, therefore, oh Lord, oh my Lord. So now we know that therefore, therefore, AC, yes, son, therefore, AC times ST is equal to, remember, we're just simply replacing this thing here by that because they are the same. It's going to be equal to AR times CT. Alright, so the proof is done, guys. Or they wrote TC, not CT. Okay, let's write it in the format that they would rather you have written it. So that is TC. That means we need to correct the CT scan here. We write TC. As well as this one over here, we write TC. So do you see, guys, a bit of a very silly question. So you need to be smart to see if you cannot find two equations so that you can replace one side by the other, and that's how you solve the problem. So I think, guys, if you have been watching my videos and following them nicely, you will realize that I've shown you the thought process that you may have to go through to formulate an approach to attacking questions. You can see that at times there is a struggle because certain things don't make an immediate sense. But a second thought or a fourth thought will help you to get to somewhere. And again, don't just give up. Keep testing things. If you guys grow up playing puzzles, you know that you try to fit something every now and then. Sometimes it doesn't fit. You have to look for the next best thing until you find the right one. So it's not always straightforward. As you can see, there will always be some questions. There's not so many marks for them, but they are pretty difficult. As you can see, this is 4 marks. It looks as if it's a little bit less important than this one, and yet this 5-mark question was actually an easier one than this one. But I may have been losing a simple and direct approach. So now maybe let's write here. What is the story? You can say each. Maybe let's be thorough here, because someone may not see what you are doing here. You can say each is equal to AS times CR. Okay, because that is what made the link so that we can complete our statement. So guys, I think this is important to show this for these 4 marks, and then of course that statement is pretty intense. And how many marks? 2 marks. And then that statement is also pretty intense driving up to that. So that's how you get those 4 marks. And guys, that is the end of this paper, however long we took. But I'm sure you will have learned something, and you would have seen exactly how to go about doing things so that you don't derail, you don't end up too far away. You want to circle. If this thing is here but you don't see where it is, it's better to be looking around in circles just here. But you don't want to increase the diameter. You don't want to be running here because it's going to be very difficult to get here. But if you're right here, you may find a dent here that actually takes you right in. So if you're moving around here and then you find this dent, you will fall in there, and then as you fall, you bump into the answer. But imagine if you are here and then the crack is doing this thing and then it's coming back. You see, you will still not fall into the thing. You're not even getting closer. So please guys, make sure you formulate approaches to these things, and the only way you can have solid ones is to keep the knowledge together, integrate information. Don't be a lazy student who will always expect someone to come up with the answers. The channel is here. I will always post whenever I can so that there is something that you guys can learn. Whenever I find questions or question papers that I think there's a lot to explain as I go through those papers, I will always post. But don't be too accustomed to just sitting back and watching, okay? But of course, we learn by observation, so do watch as much as possible, but don't overly do it. In fact, couple the watching and the observations with the doing so that you also gain experience. You only gain experience by doing, not just by watching. But you can assume a whole lot of that experience much quicker by also learning from my experiences and many others, of course, who teach in this YouTube platform. So there is a lot of room for learning here, but there's a lot of room also for going, the negative direction, because if you only want to watch and see, whenever you get stuck, you will always want to see the answers, and that's not how it works. When you get stuck, you think about it, okay? You keep thinking about it. Sometimes you will find that you'll take a question paper, do a question, and then get stuck, and you don't have a solution for it for that whole day. But the nice thing about not having a solution for something that you so desire to do correctly, it will stick in your mind. And as you go through other activities at home, whether you're watching your soapy, you're reading other subjects, you are listening to music, or you're at church, whatever you're doing, this thing is going to keep coming back. So you'll end up finding yourself multitasking in your mind. And as you do that, you will actually solve the problem because you will actually see the whole diagram. This is when you try to assume a photographic memory and you solve while you see it in your mind. That's how I got it right. At first, I got 0 for my case study for Euclidean geometry. And by the way, grade 11 stuff, but higher grade stuff was a kicker. So it kicked me because I only did higher grade when I started grade 12. So that's when I picked every subject with higher grade. So that became a mountain, a Mount Kilimanjaro. Very difficult to get to the summit, but at the same time, that summit is not easy. It's hot. I mean, it's cold. You can freeze to death in there. So think about it that way, that this is not an easy thing. Even to get to it doesn't make your life easy because it opens up very difficult career paths. Things like medicine. It's not an easy career path, by the way. I can assure you. Ask me, I'll tell you about it. It's not easy to study medicine. It's not easy to practice medicine. It's not easy to succeed in practicing medicine, which is now the ultimate. The most important is the practice because you are helping people. You are cracking diseases that are presenting rather in a very different pattern, not the usual way that the textbook is going to teach you. Certain things are adjustments and integrations that help you to get to that diagnosis quickly and to even manufacture some ways of treating. Take a drug that is used, for example, for a heart condition. If someone comes to you with a erectile dysfunction, for example, you know that you can actually use one of those drugs that you use for the heart to open the coronary arteries, to open the vessels in the man's manhood. And then that guy will stand and start doing what he's supposed to do. So you see, all of those things are discovered sometimes by someone who pays attention. You don't just learn to regurgitate that if this is this, you're going to treat it with that, but you think about what are the possibilities. Even things that have not been said, they are going to work. You can actually test them when you're running out of options, and they may just work perfectly. So I'm sorry, guys. This one, I didn't plan for it to be this long, but yeah, it became longer than I expected. So if you hate it, I don't disagree with you. I would also hate it. But if you are really a person who really wants to improve their marks, I would tell you, start loving things that take a bit longer because the more time you spend with these things, the better you become at them. But the less time you spend, the more situational and consequential you're going to be. And every time you're going to keep getting buggered by these things. So you'll hardly make it unless you're really lucky. They bring out stuff that you already are capable of doing. But my methods are essentially trying to make sure that no matter what is brought to you, reverse, sideways, front side, back side, upside down, whatever, you just will find a way of finding that link. And through that link, you crack the lock open and you get inside and enjoy the riches. All right, guys, bye-bye. Sorry for the long video. Please forgive me.